Very interesting that when I embed my link into Discord, it just says my channel name and not the title of the stream, which is quite weird. I wonder why that's happening. Happy to see project in this project so fast. Thank you. It's about like all I do really, so that's pretty cool. I did just see myself really peak on the mic like crazy, which isn't great. Also, bro. Okay, I'm just going to make my me less loud, so that we don't peak anymore. Okay, that should be good. Sorry, just have to make sure because sometimes I go back and then the whole thing is like kind of bad audio. So yeah. Anyway, I've was it yesterday or the day before? We worked on getting the atmosphere from space so that we can see the atmosphere of the planet, and you can fly up from a planet to see its atmosphere, and we got that working. I'll show what that looks like. There is still the artifact on it that we were struggling with from last stream, and I couldn't figure it out, unfortunately. So there is that, which does suck. But yeah, I couldn't figure it out. Also, I did like ask fucking ChatGPT, hey, I'm struggling with this. Do you have any ideas? And then it said, oh, I have plenty of ideas, and none of them were actually ideas, and all of them were awful. So we're just gonna call this one. However, I think that there's probably a janky way that we can solve it. So hopefully that goes well. I forget what the state I left it in was, to be honest. I remember just being kind of really tired and wanting to go to bed. So yeah, we can take a look at it. Alright, yeah, so this is... So that's obviously the artifact there. I got it to a much better... It's better now, but it's definitely not, fantastic. But yeah. So obviously that is where the sun is, even though that technically there is no sun, so or at least right now. So yeah, I'm not really sure. It's gonna be kind of hard to deal with it when there's stars going around. Technically we could just do a typical lighting calculation and then like just for loop it in here, but this is now nested looping for our samples, and you don't want to be doing that, so I don't think that we're gonna do that, unfortunately. So not sure how we're going to solve that problem when we get to it, but anyway, next thing I want to do is I want to go back and make sure that we aren't making them completely just white. I want to make them have... For now, let's not worry about lighting, because lighting is apparently really, really slow on the Intel GPU. I just want to do the V color. I don't even think that that's the... Maybe it is the texture. I don't know where I get the V color from. Where's the... Oh yeah, this was done in real time, by the way. Oh yeah, that's disgusting. That is disgusting. Okay, yeah, so we can definitely fix that, but yeah. I want to make sure that we are rendering something over it, over the atmosphere. We want to be rendering the planet's surface over the atmosphere technically, because I mean technically we don't want to be doing that, but that's how we're going to cover up the artifacts technically. And we only really need the atmosphere to just have the rim around it anyway. So I think that that's going to be my solution. Funny that even me, when I program with Python, GPT chat always makes horrible mistakes. Yeah, exactly. Yeah, it's that's what's taking our jobs. Are you making the project in some retro hardware? It is technically, it's not retro in terms of like, you know, versus like, you know, what I was doing on Windows XP, but it is Intel UHD 620, so it's integrated graphics on a laptop. So you can look up Intel UHD 620 yourself. It's very, 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 very limited, and also there's a lot of stuff in compute shaders that we can't do. So we can't do subgroup directives, anything like that. It's very hard for us to even do atomics and regular barriers. So working on this thing is very, very difficult. So even though it's not retro, doing something like this on it is very hard. Yeah. But yeah, it is a pain. Is project going to be published with source code? Yeah, it'll be on GitHub when I get to a solid point with it. Yeah. As with all my projects that I kind of put up, yeah, it'll be up. Yeah, so I want to make sure that we're rendering it on top of the thing. I may have to take this jacket off at some point. that may need to happen. So yeah, when I render the atmosphere, we render it beforehand, but okay, so we need to depth test it then. Wait, but we have depth testing on, so why are we not rendering over it? That's a good question. Oh wait, this is rendered. Wait. No, yeah, this happens. This happens here. This happens here. So it happens after. Okay. So if we render it after and we have depth testing on, then why is it? Oh, I guess it's slightly in front. Yeah, that would make a modicum of sense. Yeah. That would make a modicum of sense, yeah. That would. Okay, well that's a bit difficult actually. How am I gonna do this? I'm so disappointed. Yeah. Thank you. Yeah, honestly, if I had a really old IBM computer, I would love to program on it. I also want a PC98 and do some stuff on that, but I don't really have like the money to get like an NEC or like any of those things. I definitely wanted to do some stuff on there, but I only have 2 computers. So yeah, this is a difficult thing because we have depth testing here and it's obviously working, but we need this to obviously go on top of it. That's a bit difficult though with what we have going on here, because this is always going to be on top because it's a sphere, and so it comes closer to the camera than obviously just the fake sphere quad. Hmm. For now, how about this? How about this? How about this? Let's just not worry about it for now, and let's get the scale issues worked out, because obviously we have a big problem with scale, because right now if we start on the planet like we're supposed to, if we start on the planet, then the planet is super big in terms of everything else. So we obviously have a scale issue there that I need to fix first before we even talk about the visuals. And so I need to make everything way, 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 way bigger than it currently is. Our size function is this. And so we can either multiply by the scale, or, you know, change this in here. And so I think maybe going to this and yeah, I think just pump this up to 100 or something. Make everything massive. Everything needs to be really big. Because right now every kind of planet is about like maybe 1 or 2 units, and right now our atmosphere of one of our planets is 1,000 units, right? And so that atmosphere that is 1,000 units is about 1% of the radius of the planet. And so in that case, if that 1,000 is 1%, then really you want something that's, yeah, that's like 100,000, which is massive. Have I fixed the barrier issues? I did. So I'm gonna write an article about this later, but I had actually read about this somewhere before. I just forgot that it existed, but I'm gonna write an article on my website about this later. But so basically, what shader was that in? That was within the Radix. The Radix new. I was in Radix new. So basically, modern GPUs, right? You can simply do this. This is what everybody does, right? Basically, if you're when you dispatch to some amount, right? Then you're just going to want to, for each, you know, thread that's over the amount, right? You have extra ones at the in your last dispatch group, right? You just want to return, right? Except you can't do that on old drivers, old hardware, because each thread always needs to hit every barrier, or else it will get stuck waiting for the other threads, even though they've returned. So what you have to do is, now if our thread ID is obviously less than body count, we're just going to do work, right? And otherwise, we aren't going to do anything. We just have to stick around to hit every single barrier. So this is why we have all of these if TID is less than body count, because only those threads are workers. What we should actually do here to be, you know, way more efficient, right, is just to have a bool is worker equals TID less than body count, right? I don't know why I didn't do that before, so that we could avoid all these comparisons. I mean, actually, it's like the same thing, because it's still an if statement, but whatever. Yes, the branching is necessary because, yeah, this is what it is. So, yeah, every thread needs to hit the barrier, And if it doesn't, it just literally waits for the threads that already returned. So yeah, there you go. That was the mystery there. Most people probably don't even know that, because most people just write for, you know, NVIDIA good drivers and have no clue otherwise, because their GPU is not dog shit. You know. But we love writing for awful hardware here. That's the whole goal. Very complicated. You didn't understand much. It's not like the most complicated thing. It's just basically when you have a compute shader, right? And you dispatch it with all the threads on a GPU, right? So that's like 128 threads or whatever, right? And so you know, that's, and then you have work groups, right? So these barriers just sync within the work group, and so they all need to hit the barriers. So you can think of it as like multi-threaded code, right? So you have a bunch of threads executing the same code. You need them to all hit this breakpoint, and if they don't all hit the breakpoint, then you have issues. If you have a bad GPU, which I do. So let's see what 1,000 is. 1,000 should make them absolutely insanely massive. But then we have to make the entire field much bigger. Right now, I've got to put this in a different file, man. I had 5,000. I kind of want to... These are magic numbers, by the way, and I don't care. We're just going to put it to 50,000 now. So you found some solution online, or I cracked it by myself. I did not crack it by myself. I asked Google's AI mode, hey, why does me taking the barrier out make it run on Intel UHD 620? And then it told me why. Okay, so what we're experiencing here is all of them on top of each other, because they're all massive. So they are massive. That is true. I did make them massive. So that did do what I was... AI actually useful? No way. Yeah, I mean, I basically had the problem down already at that point, but it did give me the reason why it was happening, so... Okay, so... Yeah, I'm not gonna lie, I think that this is completely cheeks. This is completely cheeks. I mean, 10 is probably massive enough, I don't know. If, like, we're thinking logically, it should be 1,000. Yeah. But, yeah. So that's how big a planet is. But maybe we don't actually want... We, of course, shouldn't be drawing the planet that we're on right now. That's the planet that we're on right now. Okay, well, why is this happening now? Did I fuck something up? I think I may have fucked something up. I think I may have hard-coded something when we were doing the other stuff, and now it's just kind of broken. I think I probably did something with the rendering. Now what that is, I have no clue. Oh, this should start at true. Oh, well it did, it obviously hit true, yeah, 100%. Hmm. Well, that's weird. Let me try not rendering the atmosphere, actually. Let me try not rendering the atmosphere when we're outside of space, because I have a feeling like it's occluding everything else. Because we're writing it to depth. What is the black? Is that actually how big it is? Really? Okay. Maybe the scale is somehow breaking it. I don't know. Let me see if just like regular scale just works properly. I guess I don't know why it would, but I think that they might be black. I think that they might all be black, and that's the problem, actually. I think that would be probably the problem, not gonna lie. I think that the middle one being black is enough for me to now correctly diagnose the problem. I think that it's just black in, you know, space, and so everything just looks, yeah, it definitely is occluded by something. Maybe it's because we're rendering the planet's stuff. Okay, let's just try something here. Let's try not rendering any of this if we're not within the planet bounds. Okay, let's try that. I think that we're like drawing over it somehow. I don't know why. I mean, this worked last time, but you know, I may have done something and then now it doesn't work for some reason. You know, it wouldn't be the first time that happens. See, it looks like there's just something in the middle that's just blocking it. Would probably help us a little bit more. Hold on a second. Oh, it may be that they're too far out for us to even see anything. And it may be also that our near and far plane are way too small. No. I think I changed them for the water rendering, actually. Okay, so that might actually be what it is. Yeah, our view far is actually only 1000, which is definitely not enough for us to do this. Our view far actually needs to be massive. However, that's going to really affect the water rendering stuff, but let's not even worry about that for now and just pump it up. The water stuff uses a near and far plane to linearize the depth. And obviously that's going to need a change now. So that's what I'm doing. However, obviously the scaling on it is going to be very different now. So I'm going to have to multiply it by a different value. Unfortunately, this linearize function is also within other parts of the engine inside of here, and we do have to just like kind of copy and paste in it because we are linearizing the depth and storing it in the texture in the alpha channel on the textures. So let's just see if we see something now. Okay, there we go. So we see our constellations. That is correct. And now I want to space them out properly, right? To 50,000. They need to be far out because this should actually be way more than 50,000 technically, but just for seeing if this works now. There it is. Okay, so you can see them very, very far off in the distance, and that's exactly what we want, right? We want to actually be able to take off here.
Hidden value is all around you.
And now we have, okay, so now that's proper. So that's proper. I'm turning British.
And chances are
that's very good and proper. Also did see a British movie. Well, it's not really British, it's fake British. I did see The Conjuring 2 this morning. Let me tell you, not great. Not great. The first Conjuring was good, actually. I was very surprised. I'm not like a big modern horror guy. I think that modern horror is like awful, but first Conjuring was very, very scary, actually. So very, very good movie. Good movie. Mate, how are you doing? Rocking a weekend shift here? Go live deadline. Thanks. I'm glad I have your back too. That sounds intense. I hope you're taking it easy. I'm doing all right. Just doing the usual here. Nothing new. Okay, so it was definitely our far plane was not enough. Now back to what I was doing, which was changing the size of these particles. So technically they should be 1,000 if we're talking about like realistic, right? Because the atmosphere is 1,000. Then technically, if that's 1%, then technically this should be, well, I don't know what it's at right now is kind of the problem. I don't know what it's at right now. Alright, let's try this. If every body had the same mass, then it should technically have 100,000 as the radius to be physically correct. And this is exactly what I was worried about, that we would just end up in white space. Yeah, this is kind of ridiculous. I kind of think maybe I should. Well, we want to not draw the one that we're on already, but yeah, we may have to do that then. We could just skip it if so if or ID equals 0. Okay, so we just won't draw we won't draw the particle 0, which is the one that we're on currently, just for testing this. Oh my gosh, this is laggy. Okay, so yeah, they're really big. They are really big. They are really big. Okay. That much is very true. Okay, maybe physically accurate isn't possible. Have we considered that? I don't think we considered that physically accurate might not be possible. We might have to pretend. Yeah, that's pretty massive. Yeah, I'm not gonna lie, that's pretty massive. These are pretty massive. But how does it feel coming off of it and going down onto it? Right about now, we've exited the atmosphere. And now we've entered it again. So that's about the size. It's 1, 2, 3, 4, 5, 6, 7. There. I feel like that's pretty solid, actually. 100 might be it. We might just have to really space them out. Like right now it's 50,000, but we might actually like have to go to like at least 100,000. I mean, 100,000 doesn't even probably bring us close, to be honest. We probably need 500,000, but we can't even see that far is the problem. And I don't really know how I feel about our near and far plane getting to 1 million. Seems like pretty crazy. That sounds like a really big view far. That's definitely the furthest far plane I've ever done, by a large margin. I don't know if that's stock standard for like space simulations, but I feel like that's a very large number. I'm not sure how the depth buffer is really going to work at this point. We may have to use a different view plane, different parts in the. We may have to have a different velocity once we exit the atmosphere. Yeah, we're really slow. Okay, so I feel like that's good though. That's pretty solid. Okay, let's do that. Now when we are outside the atmosphere, we want our velocity to obviously be increased. So we have to change that. How do I do this? It's not a global. It needs to be a global. We're gonna make it a global. I think that's what I called it, right? Within atmosphere. Okay, I didn't name it that. That's fine. What did I name it though? I would love to know. Within planet atmosphere. Ah, yeah. You gotta really be specific there, for sure. Yeah, there we go. Within planet atmosphere. That's what I called it. Gotta be specific. Okay. So, obviously, we're not gonna apply planet velocity. We're going to be applying the not planet velocity, which is a different function. It's apply velocity. So since it's a different function, we don't actually need the variable. We could just like literally pump the max speed to be 100 seems good. 100 does seem good. And our acceleration is obviously going to have to, you know, go up to like 5. Let's see how that feels. Yeah, the second Conjuring, it feels like they were phoning it in. I don't know. Kind of weird, because the first one was really good. I liked it a lot, actually. Okay, so oh, we're in the core of the Earth. I see. Yeah, so that's also the thing, is that now we can go around the planet, which is not really what we want to be doing. But that's a problem. So this is us literally going around the we're going really fast right now, by the way. We're like, this is like insanely fast. Because I turned up the velocity so that we could. I don't know what that's doing. I just want to see up close, like how big they get. That doesn't feel like big. Up close, that really does not feel big enough at all, to be honest. That feels very small. Yeah, that feels way too small. Which, you know, I am correct, because that, you know, physically we are kind of thinking that this does need to be. Okay, so instead of doing this, what we should literally be doing is just like hard coding this for now, because this should technically be 100,000 if we're being completely honest. If we're going based on the physical atmosphere calculation. That's gonna be massive also. That's gonna be massive also. That's gonna be massive. So they need to be further out? feel like I'm doing a never-ending like moving the goalpost thing right now. Planets need to be big is the problem. That is kind of the problem. So yeah, this obviously is. They're all coming towards the center because they all want to collapse the simulation. Okay, I think that this might be big enough. The problem is that they need to be split, you know, further out, I guess. But this does feel big enough now. Maybe not even. Yeah, probably not even. Yeah, I mean, technically, yeah, I mean, this 100,000 should be correct. So if 1,000 is the atmosphere, then that is 1%. So why doesn't it feel good enough? Why does it not feel good enough? I guess it's... Ah, bummer. Yeah, I'm not sure how I feel about that. Am I sure that I didn't cap the size somehow? Maybe I capped the size somehow. I don't think I did. No, I don't think I did. I may need to look at different like projection matrices or something like that. Yeah, so I mean, unless that 100,000 is not actually. Oh, wait a second. We didn't actually. Oh, yeah. So that's my bad. Yeah. We weren't actually rotating it into camera space. As that. Yeah, this is just really massive. Yeah, 100,000, and they're only spaced out to 1 million. So that is really massive. That kind of feels right. I mean, you probably want them actually, you know, to be that 100,000 is what I'm going to try and go for, but then we need to push them out even further apart. We need bigger numbers. At this point, I mean, it's so much progress. Yeah, right now we're not really looking. I hope that the thumbnail shows a little bit better, like what I'm working on, rather than the current. I'm just kind of debugging right now. But yeah, it's I'm just kind of playing around with different values because I want to make. Oh, what I'm trying to do right now is I'm trying to scale the planets properly, so that they actually match the atmosphere calculations. Yeah. So that feels about right, actually. Yeah, now we just pump the velocity. But yeah, a planet should be about that big. We just need to space them out more now. Yeah, the planet should feel massive as you approach it, yeah. Of course, this is going to be how a big body is rather than, you know, something else. But yeah, it should feel like that. We do unfortunately need to push them out a lot more. And so now this value is just getting insanely big. Like, that's an insanely big number. Like, what is that, 100 million? Yeah. Yeah. That's insane. That's a very large number. I'm kind of worried about, like, overflows once we get to that, like, sort of point, because our masses are going to have to get pumped up as well. And so our numbers are going to get pretty massive. But I have no clue how to avoid that, really. Our plane is 1 million still. Yeah, so that it does match still with our linearized stuff. So 100,000 should be the size of a planet. Now, how to translate this into the function, I'm not really sure, because our masses haven't really. We need to find a way to translate what our mass was before. It was 100 to 1,000, but that was really just within the testing. Now we're probably thinking about something like Trying to think how many zeros we're talking about. Like 1 million. We might have to get the calculator out for this. 1 million to 10 million. What is that? So if we do the actual calculation here. Let me do the calculation for this. Okay, so if we do 10 million to the power of 1/3. Oh, well, you can't actually do that. Well, to the power of 0.33. What is that? So that's 204. That's 204. And so we would have to multiply that times what to get 100,000? So multiply it times 5,000? No. Really? Times... Oh wait, I'm trying to go to... I'm not even trying to go to... Oh. Oh. Wait, then I can just literally do... What is that? 200 times 500? Yeah, times 500. Yeah, I'm so dumb. I was trying to go to 1 million, but I was trying to go to 1,000 instead. So this is times 500 now, then. Yeah, that's what I decided. So that's times 500 at maximum. But this is a star, and we want it to be a planet, actually. So actually it's 1 million. So it would technically be even less. Or wait, no, it would be more because we want the planet to be... Well, this wouldn't necessarily be a planet. It would probably be somewhere in the middle, so... I'm thinking like... let's just leave it at 1,000 and then see how that looks. Yeah, let's try that. Doing math and stuff in math. Alright, I think that should be good. Okay, yeah, I'm gonna keep it a buck with you. We really gotta pump up the velocity. Because these guys are far out now. Oh my gosh, I was not kidding. Those guys are far off, man. Alright. Those guys are really far off. I was not kidding. Oh my gosh, even this is slow. Oh my gosh. Oh my gosh, this is like molasses. Jesus. Okay, yeah, we gotta not do that. Telling me 100,000, really? Okay, the numbers have gotten pretty big. I'm not gonna lie, the numbers have gotten pretty big. But hey, planets are big, I think. Okay, so this obviously is not big enough. This is obviously not. Yeah, definitely not big enough. So I messed up my math bad. I either messed up my math or this just is not working. So let's just, instead of doing this, let's just literally do let's just make everything, let's make everything the smallest value and then go from there. You missed out on 23 parts? Yeah, that's a lot. Should celestial bodies be that close? Not really, but that's what we're working on right now. I'm scaling them properly. We break out of the atmosphere. Yeah, so those are basically the smallest particles though. So that it's, those aren't like stars or, you know, any planets or whatever. Also, it's not really simulating right now. It's just kind of, yeah, if you want to look at like the lighting and the what it used to look like, then you can look back on the other streams. But yeah, I'm just trying to figure out how to get it to match the atmosphere calculation right now. Yeah, I guess that 1000 is not nearly enough. Okay, so this is 1 million to the power of 0.33, which gives us 95. Yeah, so this is just times 1000. The math isn't mathing. It should equal 100,000. How is it? It's good. I'm just, I'm trying to scale the bodies now to be physical size, which is proving to be a little bit more difficult than I thought. Yeah, this is confusing now because I just had this. Was it really this? Like, wait, what? I thought that 100,000 was what we decided on was correct, but now. Oh yeah, this is way too small. Maybe it was 1 million actually. I think it may have been 1 million that we decided on, and then I just forgot that we decided on 1 million. You and Halle Berry use Emacs? Okay. What do you think, you're like better or something? Emacs. That's alright. I mean, I wish I used Emacs. I wish I was that cool. Unfortunately, I'm not. This does not look nearly big enough, sir. Call them a berry? I mean, what movies has Halle Berry been in? Because I feel like none of them are good, right? Why do I feel like I'm in a never-ending loop of making this bigger and then it not feeling like it's big enough, and then just making it bigger and then it not feeling like it's big enough, and then making it bigger and then feeling like it's not big enough, and then, you know, like I feel like I'm stuck in a time loop. I feel like I'm stuck in a time loop, you know what I mean? I mean, like, how big can these numbers really, like, realistically get before we, like, start overflowing? It's all that you know about space or whatever. Like, how big are planets supposed to be, genuinely? But, like, in my units for this specific simulation. You're nothing but a hound dog? Alright. Very, very big. Like Halle Berry? I think how we're rotating this into screen space is making them have a weird thing. That's what I think. I think rotating them into screen space is making them have a weird thing. That's what I'm gonna say. Wait, but like, I mean, like, surely, like, 1 million times this is obviously going to make it 1 million, right? Like, you know, if I draw a giant ass GL points, then it's gonna draw a giant ass GL point. You know what I mean? You feel me on that one, right? All right, peace out. I'm still fucking with the recursive tic-tac-toe. I started to pose questions on my existence like Descartes. Dude, jeez, chill out. Chill out. That's crazy, dude. That's crazy. I hope you don't you don't like ended up like a Kantian philosopher just because you can't figure out some recursion, man. Chill out, bro. It's not that serious. Okay, what if we don't do this? What if our pause is just... Okay. 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 Got it. Got it, got it, got it, got it, got it. Okay, so I think I just realized, I think I just came to a realization here. I think I just came to a realization here. I think I just came to a realization here. That this size only changes the center. Wait, no, it doesn't. It doesn't, because the UV is our GL vertex ID. So that makes a ton of sense actually. So that should be making this massive then. This should be making this massive. But why is it not massive enough? Why is it not... I feel like it should be massive. Let's just make it a quad now. Let's just make it a quad, just so that I can prove something here. What do you want me to do? I spent 2 weeks on it. Dude, listen, if it's taking a toll on you, you gotta have a break. You undeclared. You're undeclared. You undeclared. What do you think about that, huh? Yeah, this doesn't even matter. None of it matters. Just comment the entire thing out, actually. Why does it not feel scaled to the correct size? Okay, but like, listen, just comment the whole goddamn thing out. How do I do this? Okay, we get it. I mean, like, actually, like, at this point, I mean, dustmite, in your opinion, what should a less than 10 months programmer should be able to do? I don't know. I don't know the answer to that question. See, this is the problem. The problem is that they're either way too big or they're too, like, this is the problem. Oh my god, bro. Like, what the fuck am I supposed to do? Like, this is ridiculous. There's no way that that's supposed to be that large. there's no way. I didn't even recompile. I'm getting annoyed, to be honest. Why don't they seem big from up close? Or is it just... Okay, well... Okay, I don't think making the numbers any bigger is helping us out here. I have a feeling that making the numbers bigger just isn't doing what I want it to. Maybe how I'm rotating it into screen space is inherently making things... Okay, I'm gonna try them billboarded at this point. I mean, they are already billboarded, but I want to try it without using the camera matrix at all. I want to try it without the view matrix being a part of it there. Okay, well. Why would that? Oh. I see. You need, because this is just, Vec 2. Right, so it's not in 3D space. So do you just then do like I mean, you just have to define like a singular basis for it or something? Something like that. Okay, that's basically what I wanted to do. You know what I think? So here's what I'm thinking. I'm thinking it's all about perspective, actually. So I think that oh, that's pretty cool, actually. So I think that the fact that we move fast makes things appear small. I think that that's the realization I'm coming to. So I think I'm just like incredibly stupid, to like be completely honest. I think that they were actually completely fine in terms of scale. It's just us, our speed that was problematic. That's problematic. So actually there's yeah, so we were completely correct the whole time. So this should actually just be 100,000, and we should just go back to 1,000 here, and it's just was that in the beginning. So I was completely off. I'm trying to think what our setup was for it beforehand. I think that this was like 1 million, right? And then that one was 10 million. Yeah. Okay, you know, just a little bit of a detour. Who cares? Who cares? I sure don't. Yeah, we still want the speed to be... So it comes down to speed. I think it comes down to speed at the end of the day. Speed is actually the important thing. Because if you move very fast, then everything seems tiny. Okay, so this was too big. What was it? I think it wasn't it 500? I thought that this was 500 for 1 million. It may be the spacing. Also, it's kind of pointless for me to be doing this. I don't even know why I am doing this. That shouldn't even be in the picture because it's done in a sphere anyway. Okay, there we go. So now things appear, they appear big because we are fast, okay? But if we were going slow, then it would appear, okay? It's all about perspective. Fellas, it's all about perspective. Don't get it twisted. Okay. So I'm glad that we figured that out. I'm glad that we figured it out. They do need to be spaced out a little bit more. So I think that we're just gonna go to that. But yeah. So the numbers still are pretty big, but yeah. Yeah. Alrighty. Okay, so back to what we were doing in the beginning. Also, something I noticed is that our speed is really fast on the planet as well. It's obviously, like, not supposed to be, but okay, cool. So now the next thing is that they aren't really moving, which was like a question that I had, I guess. I guess they're so far apart that there's no force acting upon them. Or are they moving? I don't think that they're moving. I'm gonna just set them to have velocity. Oh, actually, yeah, this needs to be really, really, really big velocity, actually, for us to see it. Actually, even bigger than that. I'm just giving them centripetal velocity to start with, just so that I can see that they are, in fact, integrating the positions. Because they're so far apart now that the whole thing is off balance. Okay, yeah, so obviously they are moving. They obviously are moving. And as you'll see, that hole that ends up coming up there is because they all have velocity, and so they start to spread out like that. But yeah, it probably just makes the they probably have, it's a hard for them to pick up velocity, I suppose. Yeah, it's probably hard for them to pick up velocity, huh? Because yeah, or actually scaling for the mass might be too small. Or yeah, might be too small or big. Yeah, this is gonna collapse. You can tell it is because the top is coming down. It's starting to trickle down. It's just happening very, 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 very slowly. We're also not even at 60 FPS, which is concerning, I suppose. Yeah, so yeah. Yeah, it's hard. Alright, let's see that. I mean... the goal is for them to actually be able to move, even if the scale of our entire space is, yeah, now everything is just so small. And it's not moving. I assume that pumping up the mass would make things move a bit more. We just pump up the mass and then turn down the scaling on the mass, I think, is the goal. Hey Cheese, what's up? Yeah, I think the way we construct our tree might actually be collapsing because of the yeah, the way we construct our tree might actually be collapsing because of the big numbers. That's not good. That is really not good. There's a way for us to actually prove this though. We could just run a brute force test on it. Let's run a brute force test on it. Do I still have the code for this? I do. So literally just do the brute force thing here instead of walking a tree, and just to test if our tree is broken. Or not necessarily broken, but if it's not able to handle... What I'm scared of is that we are overflowing possibly the Morans or something like that. So let's just try this. It should just work. Oh. Entry.pid. Alright, so let's give that a try. Is the song in the game? No, yeah, it's just some PC98 song. I'm doing well. Just trying to figure out how to bring the simulation together with the planet surface thing. So we're lagging a lot because because we're doing a brute force test here. I don't see any movement though. I don't see any movement. Brute force, basically every particle is working on every other particle. So I'm gonna assume that it isn't that actually. And that our maybe our scale just Is this just gonna end with us going back to the way things were? Because I think that that's what's going to end up happening here. If I'm being honest, I think that we're just gonna go back to the way things were. Instead of making things big, just make the camera go slower. I think that that's just the way to do it, to be honest. Yeah. Yeah, because the numbers just work out better that way. It's just that simple for the actual simulation thing. So, and it also is nice for us because then our near and far plane just end up better. So this was basically just a huge waste of time. What happened to the ground? The ground is there. We're just not on it. Oh, what happened to the ground? Like, why isn't it funky and where's no water? I just have them disabled for reasons while I'm working on this. We're just very fast. We're just very fast and the mass is very small. Okay, see, they're moving. So that's the difference. See, it's moving. Yeah, I think just with big numbers, it just gets kind of really slow. So I think we just keep it with small numbers. It just works out better. We do need to make them a bit bigger though. Like, this is kind of very tiny. For this we can just like literally scale them up like this and just keep the small numbers everywhere else and then just turn the camera speed back to what it was. It sucks that we aren't hitting 60 FPS on this. That really sucks. Okay, so they're very large now. Yeah, I take it back. We can't scale it like that. We have to keep it like 1 to 5 scale and just up the actual mass. Because I feel like the POW on this might not even be working properly. Or maybe it is and I just don't know how numbers work. But I feel like we should be seeing more movement than we are right now. Oh, that guy's moving. Okay, yeah. So we are starting to get movement, yeah. We definitely look a lot better with lighting, but I turned the lighting off. I should probably get that working again, to be honest, but it was lagging the Intel GPU a lot, so yeah, this is going to definitely collapse 100%. Well, I think I'm okay with this scale. Like if we were slower, then it would definitely be different. Okay. Okay, cool. So we've stabilized the numbers now. Now does our near and far plane need to be, or did our far plane just need to be that crazy still? I don't really know. So 50,000, I don't think it needs to be that crazy anymore. We can make it 100,000 again, and that'll make the math better for that. Okay. What now? We can try making the lighting cheaper, which is not going to be easy, but we can try. I kind of wish that we could make it 60 FPS though, even before that. So maybe we can think about how to make it 60 FPS before that. In terms of the compute shader stuff that's going on. I wonder if the work groups, us bringing down the work groups even helped. Because we brought down the work groups because of the lack of cores on this GPU. But I'm not sure if that actually helped us or give us more problems. I really have no clue. Yeah, I was kind of tilted there, not gonna lie. We can actually, okay, so that's what we'll do. We'll turn on the profiling information and see if we can profile what's going on here. I have all of these queries that I had set up before that we can take a look at to see what is the expensive thing that is slowing us down. I just want to make sure that they're all set up properly. Yeah. Yo, what's up, Max? How's your vacation? How was your vacation? Do you think I should be a Twitch streamer? I was thinking maybe I switch to Twitch. I kind of can't switch to Twitch. That's the problem because now I'm monetized. It was great. Nice. Came back yesterday. Nice. Yes, I should. Yeah. I saw people actually get like viewers on Twitch, like coding people. Okay, so I see nothing other than calm taking 15 milliseconds. Which is not correct at all, probably. Or multi-stream. Yeah, I don't have the ability to because my encoding on my computer sucks, obviously. That's why we're 720p, so. But I don't know. Now that I'm like a YouTube partner, it seems like bad. I don't know. I could do restream, but then that's like $15 a month, and I don't have $15 a month. Can you believe that I haven't gotten paid from YouTube yet? I have to hit $100 before I get paid. Isn't that insane? That's crazy, right? I mean, I'm almost there, but it's still crazy to me that I have to hit the payment threshold. Like, what the fuck? Isn't that's bizarre, right? I don't know. That's just insane. Scary. Yeah, it's crazy. It's literally crazy. Oh yeah, this one I have twice. That one I have twice. Yeah, if you have one of these timers off, then the whole thing breaks. I gen queries for all of these, right? Like I'm not tripping, right? I definitely gen queries for all of these. Okay, let's try it again. Is cursor any good for coding? The AI thing? I mean, I don't really know anything about. I've never used an agent before, so I have no idea. I have no clue. Oh fuck. So we still only see com. Com is getting 16. I would love for the queries to work. I would love it. 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 I do not want to have to run GL finish on all of these. That's what I don't want to. Oh, hold on a second. Hold on a second. Hold on a second. Hold on a second. We may. We may have one. During sim step, our queries are done. We don't have one that it's happening here. I just want to get rid of all of the other queries just in case they are causing something weird to happen. Yeah, this is what I was having a problem with before on Intel, was sometimes the queries just don't work. Sometimes the queries just don't work, and I can't render dock it because it's compute shader stuff. Hey, what's up, Shark? Do people use it? And I want to know if it's any good. Yeah, I mean, it's mainly used for like AI. Like, that's what it is. It's like AI, right? So I would not know personally. I wonder if I get rid of the ComQ thing. If I get rid of this query, if the rest of them work, I still think that the com is probably the most expensive part of the loop, but I do want to see what everything else is profiling at. I can check it on NVIDIA, and technically it should be, you know, the ratio should be similar, but, okay. Okay, so no, we don't get anything. It just shows us 0, 0, 0, 0, 0, 0, which is really not what you want to see. If this is genuinely 15, which it honestly might be because of the GL buffer sub data that we're doing here. And we do GL get sub data here as well. This is incredibly slow. The reason why we do this is because we want to break out once we're through the whole tree, right? Yeah, I remember that. And so this is how we know, instead of going to max depth and going down, it would be this the other way. I wonder if this is any faster though. I wonder if this is any faster. I'd assume that it would be. Yeah, it is. It is simply faster. I wonder if it's working though. It's kind of hard to tell. No, I don't think it is. Oh wait, no, because we just went into the atmosphere. Yeah, these bodies would definitely be interacting, so it's obviously not working. We can make this work though. We should not be having to use GL get buffer sub data. We should not be doing that because obviously com just goes down from 15 to 10 just from us doing that. So it's obviously a massive save in terms of time. How do I fix it though? Depth offsets goes to max depth +1. So yeah, that should work. I'm surprised that this GL buffer subdata works. To be honest, I'm very surprised that this works. Because it basically, it makes us stall the GPU. I'm trying to remember what this code actually does, and it's pretty confusing. We did this live on stream, actually. This current depth offsets is basically a running counter of our, you know, the current amount of nodes in the tree. So I'm just wondering why this doesn't work when we... Oh, right, because we don't get A out. Right, right. Right, yeah. If we don't read A back to the GPU every time, or to the CPU every time, then... Yeah. Yeah, so instead of reading A back to the CPU every time and then going down, we should just keep depth offsets on the GPU. I'm not sure why I was so intent on not doing that before, but yeah. We should just keep it on the GPU instead of the CPU. So this ready queue thing, just like get rid of it and instead just keep the depth offsets on the GPU. This is depth offsets to max depth. And so instead we'll just, oh god, how did I code this? I remember this was so painful when I tried to get this right the last time. Oh man. Ready queue amount. So yeah. How do I read out to A? Because A is what... Where do I increase that variable? I have to have an atomic ink somewhere here that increases it. Q out, that's what it is. Q out, right? That has to be it, right? Q in and then Q out, and then we bind the node counter SSPO, and then that's this. So we are reading Q out. And then we put it on the ready queue. And so what we would be doing instead of this queue out would be the depth offsets. So it'd be depth offsets for depth. For depth. Or depth plus 1. It should be depth plus 1, but just for simplicity's sake, I'm just going to do that. So depth offsets for the depth. Technically, this should be depth plus 1 since it's the queue for the next one, but hopefully that's fine. And now that saves us. We technically don't even have to GL buffer subdata here. We only have to subdata it before we start. We have to just fill it with depth offsets. So depth offsets goes to max depth plus 1. And technically we want that to go to max depth plus 1 on the GPU as well. Or do we? Also, isn't this depth? No. We're going from... Right, we start at the leaves. So technically this would be depth plus 1. That would be depth plus 1. So we do have to go to max depth plus 1. Which is annoying. It is annoying because now we have to go to other places that have this and then go max depth plus 1. Are we ever going to hit max depth plus 1? Probably not. But we are going to iterate it. So technically you do wanna... Yeah, that's kind of a pain in the ass, I'm not gonna lie. That we have to put max depth plus 1 on this all the way through everything, but... That is kind of a massive pain in the ass. Oh, that's not even the full struct in there. Well, that's not good. That is not good. That is not good. That is not good. Okay. Okay. This file here is not good. Okay. I'm gonna BCO this. Okay. Okay, so now we're writing into depth plus 1, which is what we want. Okay. I've gotta really clean this up. I'm gonna do that after this. So we want to be writing into not node counter SSBO, but we want to node SSBO, and we need the offset of node data. We want the offset of depth offsets, and we're going to do size of depth offsets and depth offsets. Okay, so let's go to node data, And now this also needs to go +1. And obviously this has to be uint 32t. Okay. And I don't know why we're starting 1 with body count and not 2. This should technically, why does this, what the hell is my problem? What? I don't know why I did that. Anyway, so we don't have to do this anymore. This queue in doesn't exist anymore. Queue in will just be the depth offsets for depth. Right. And ready queue the amount. Right. Okay. I have no clue what I'm doing, by the way, and I hope that I am not fucking this up really bad. Okay. And then for next, all we have to do is reference the oh, we're not even using any of that. Oh. Oh, so we're already brute forced. Okay, well, then let's give this a shot then. Hey Ahmed. How are you doing? Buffer depth offsets, shader link error, buffer depth offsets. I wish that I told me which one. Yeah, that would be That would be that. That would be that. This is also it, but this by the way, this doesn't even exist. But yeah, that file doesn't even exist. I have a microbiology exam tomorrow, and I know nothing about it. Oh no. You should study. Good luck. What is microbiology about? Is that like biology but for small things? Okay, so this is working. This is actually working. We have particles that are acting on each other. These are gonna kiss. They're gonna kiss. Oh snap. Beautiful. Beautiful. The mitochondria is the powerhouse of the cell. Is that what it's about? It's about like microbes, viruses, and fungi. You know what I got schooled on? That cache is not cache. I say cache. Like when I like am talking about I'm gonna cache this value, like talking about programming things, I say cache. It's actually cache. And I got made fun of for it. It kind of sucked. Anyway, com is down to 12, 13, 13, 14. Honestly, it's about the same as it was before. I'm not gonna fucking lie to you. Yeah, I have no way to actually profile any of it. So what is max depth? 64. Yeah, that's pretty strong. Have I read books lately? Honestly, not that much. I've been just kind of doing this. You know? We just need depth. We don't actually use current depth offset or any of that shit. We don't use any of this here, by the way. This to max nodes, by the way, this is a massive thing. We could check here, actually. We could check what the highest depth was. I mean, but that is a lot, actually, because we would have to map a buffer out. We would have to map the buffer out into these depth offsets. We'd see how expensive that is. It would basically save a bunch of dispatches here. I don't know if it would make it much cheaper, but you know, save a bunch here. We could actually see how expensive this is versus this. Yeah, I've not read books lately. I really want to read more of CSAPP, but I just kind of have been coding a lot, so that's kind of what I've been doing. Alright, so let's see what the profiling says. So it says 7, so it's about half of it actually is within here. Yeah, about 7. Yeah, let's turn back on the Yeah, it's kind of annoying that these queries don't work. I really want them to work. Like, the queries just do not work. I'm just gonna try to maybe get just one to work. I just want the main to work. I want to know how much this is taking up, you know, this time. How much time that's taking up. Sorry, I'm just trying to profile today because I need this to run on this GPU. Yeah, it doesn't say. It does say that we are at 60 FPS though, which is nice. It's not like the greatest thing in the world because we don't have lighting or anything. So the fact that we don't have lighting kind of, it's a damper on things for sure. Yeah. We may have to brute force the profiling, unfortunately. We may have to brute force it. I think that it just doesn't give timers unless it's a lot. Like, it only gives us timers for the largest part of the thing. Like, if it's just a few milliseconds, then the queries don't work on Intel. So the queries aren't going to work. What instead we can do is actually do timers. We can actually make timers and then just actually use your words. We can make timers and then just GL finish after every single call just so that we can profile. So that's what I'm going to do. We will make the same things as there are queries and just replace the queries with them while we're on Intel. And that's what I'm going to do. That is what it has come to. I actually asked AI about this because I was noticing that the queries just weren't working. And I said on Intel UHD, the queries just simply don't work. And it said just GL finish to profile. And I was like, yeah, that sounds like not what I want to do. But that's what we have to do. So there we go. It's so funny because you like look up like, why does this not work on Intel UHD, and to Google, and it's like, yes, nothing works on Intel UHD. Why are you developing for Intel UHD? That's like literally what it says. That's like what the AI overview says. It's like, yes, idiot. Nothing works on that stupid driver. Why would you assume that anything would work on that piece of garbage? Like, jeez, dude. This is miserable. This is miserable. This is miserable. Okay, so now we have to go through the list and I actually applied to this internship that I really want to get, but I don't know if I'm gonna get it. But yeah, it's this cool independent game studio that was looking for people. They have an in-house engine that's in C, and they work on constrained hardware, which I was like, you know, like, holy shit, no way, right? Like that's actually just like what I do, right? But I'm just gonna call this one moron because I feel like it. So I sent an application, but I don't know what's gonna happen. It's one of those things where it doesn't actually pay like really good money, but honestly, like, I don't really care about the money. I would rather just like do something that I would enjoy. Like, if I had the choice between like a job like that, doing like literally like something that like is like what I do, versus like working at like a big game company or like Nvidia or AMD, I would choose that any day of the week. So that's just kind of who I am. So we're obviously gonna lag a lot, like we're lagging, but at least we have profiling information now. So this is in milliseconds. So 7, 5, 4, 8. So automatically what's jumping out to me here is bounds and tree count are not expensive operations. Should not be expensive operations. Yet they are very, very long. Bounds literally just calculates the bounds of the place, of the thing. So let's do a test here. Let's not include 0 into that, and let's see if it's 0. For whatever reason, zeroing some arrays is expensive. Radix should be expensive because it's, you know, a radix thing, and then tree count should not be expensive. Tree count just zeros things and does things. Oh, but this includes the tree. This includes the tree, yeah. So let's just see that. Very interested in the fact that main is nothing. Unless we miss the GL finish there. Okay, so yeah, tree count goes down to 2. Still a lot. Okay, so bound stays a lot. Okay, so yeah, that prefix. Yeah, I wonder if maybe we just do the. Yeah, the bounds being expensive is a pain because I don't really know how to make that any faster. It's a it's like a prefix sort that I copied. So yeah. Main is nothing. Did I miss the GL finish there? I did not. Really? Yeah, so it looks like com is still pretty big. So looking at this all together, so this is relatively like 10, 13, 18. Yeah. On NVIDIA, it's probably nothing, but yeah, if we're gonna do this here, let's try 256. Let's try upping the num work groups. Now that we have the everything set up properly, I want to try pushing the num work groups back up to 256 and seeing if that solves something. Which does suck since we have to do a bunch of copying and pasting here. But I do need to check it just to see what the speed up is going to be. And if not, we can obviously just run it back really fast. It's not like the end of the world. This is the worst part about having like 20 different compute shaders, is that when you need to change something that's across all of them, it's like ridiculous. It's really painful, obviously. Like honestly, what we should do, what I should do is I should have I should set up like compilation of literal text that happens on top of these, so that we change it once and then it compiles into all of them at the same time. I never set that up though, and honestly I don't know how I would set it up. I should like look into that, to be honest. But all of this seems to be 256 now. We also need to change it in here. Alright, let's see if this is any faster, and if it isn't, then at least we tried. But I assume that it would be faster to have less work groups because there's just less cores. Yeah. Yeah. Yeah, that's way worse. That is way worse. Okay, so that proves my point. That proves my point. Yeah, we should really fix this because we should have it so that depending on I guess whatever, you know, whatever, you know, architecture or whatever that we detect, that we I don't think we're out of shared memory. I don't think so. I want to try this with 64. I want to try that with 64. I have a hunch about the barriers there. I think synchronizing things on this GPU is just awful, and so 715, 514, 16, 10, 6, 4, 4, 4, 4, 16. Why does it spike like that? That's so weird. Why does it spike like that? Maybe I'm not built for this. I don't know. Let's try 32. I think 128 might actually be the sweet spot, unfortunately. Five, 8, 7, 8, 8, 8, 7. Yeah, that's about what it was. It's about what it was here. Yeah, it's slightly better. Still does peak to 10 though. Actually, it might just not be better. I don't know. It may be also that I'm interpreting the data wrong, maybe. I wonder if it's faster to just do a single pass over the entire thing. To find it. I wonder if it's faster to just do a single pass. Instead of doing any of this, I wonder if it's literally faster on this GPU to just find the bounds just manually. Watching B stars? What is B stars? What is B stars? I think I've heard of that before, actually. God fucking damn it, I can't type. Just like literally do this. Or actually we could just like use the built-in functions. Just go min equals min. Or actually we can't name this min. You have to go like mm. And then mmin equals the min of mmin and the pe.pm dot xyz. Yeah. And then just set at the end, just set okay. Let's see how fast this is. If this is faster, then I mean, like, seriously, what the fuck is this GPU even? If this is faster, then fuck this GPU. That's all I have to say about it. What are we talking about? What are we talking about? I didn't code it wrong. What do you mean? Mmin used uninitialized 75? That's not true. This is initialized here. What? .68 type mismatch. Oh. I meant P0 dot, yeah. That's what I mean. That's what I meant. That's what I meant. That's what I meant. That's what I meant. Yes, I know. I didn't start at 1. I know. I get it. Cannot be value uint. Oh right, I have to do the fucking float to float bits to you, float to you, or to uint. Yeah. I'm all over it. I'm all over it. And all of this just to profile. Just to see if this can be faster. No, it's slower. It's slower. It's actually a lot slower. God, this GPU just fucking sucks. That's what I'm realizing. It just fucking sucks. Jesus Christ. Are you serious? It's not even, it's literally, like what? The fuck do you want me to do? Like what? Dude, you have to be like joking. You're funny. Like you're being funny. You're being funny. Are you fucking kidding me? You're fucking being funny or what? Oh my god. Oh, by the way, this is the exact code that I just wrote. It's down here. Okay, well, now I'm tilted. Now I'm really tilted. I'm tilted now. Now I'm tilted, yeah. Alright. Well, glad we did that. What IDE? I mean, yeah, this is a Helix. Alright. Yeah, let's never do that again. So, what did we learn here? We learned that developing for Intel UHD 620 is too hard. There's not much that I can do here, unfortunately. It's not even body count. Like, even if we drop body count to like a lower amount, it's not even body count. It's just literally the GPU is not capable of doing anything compute wise. It's literally just the barriers. It's legitimately just the barriers. Like, if I get rid of all the barriers here, it's gonna run so fast. It's like, maybe it's not even the barriers. I don't know. There's definitely going to be a lot of race conditions involved in this situation now, but no, yeah, it still takes forever. It still just takes forever. Yeah, I mean, yeah, I don't know. I thought, like, here's what I was thinking in the back of my mind there, was that we could technically have like a back buffer that we map out, that the CPU actually, that there's a CPU thread that is running in the background that is doing the bounds asynchronously, and every time it gets a new bounds it just gives it to the GPU. The problem is that mapping that buffer out would be more expensive than this That would be a massive buffer. So, is that custom UI in the sim? Thanks. It's not actually custom now. It's that's just nuclear. Yeah, I do have my own UI like library for the game engine, but yeah, it's not that. Oh man, that's such a bummer, man. Also, these numbers are larger than they are in practice. This is just a this is just like basically giving us a little bit of an insight into which are the actual like expensive parts. The GL finish is adding so much overhead into it. In total, this happens in 60 FPS currently. It's just, we're just, you know, taking a look at what the expensive parts actually are. And it turns out that, like, the expensive part is actually just, literally what this is all this is it just calculates the bounds of all of our particles in terms of, like, which one is the furthest in each dimension, you know? So none of the actual like physics, math, or anything. It's just the fact that this GPU is so bad that it has problems with very simple things. And actually the most complicated things happen extremely fast. So yeah. Yeah, not that much I can do about it though, unfortunately. Just have to live with it for now until I figure something out about it, I guess. I gotta. Not much I can do. Okay. So now we got through that. I guess so. The next boss is actually the lighting math. So the lighting is very expensive now, and so we have to do some things. Even if we cap to 1 star, I think that it's still extremely expensive, and we need to think about it here. We have to think about it. I think that it isn't even that. I think that it's the fact that this is expensive. Us looking up this particle is so expensive. Because that happens per fragment, not per... That happens per fragment, you know. But we can fix that fairly easily, actually. I'm just gonna BCO this, and then we can fix this fairly easily, because we can just send vColor equals color, and then just check the mass, and if the mass is 0, then color just becomes nothing, right? So if e dot p position mass dot w is less than or equal to 0.1, then color equals that, and then we can just check that here. Instead of fetching the actual particle, because that's expensive, we can just check if vColor, if the length of vColor is 0, then discard. So that's just the way cheaper way of going about it. now we just have to obviously make sure that center shouldn't matter because we're using vCenter anyway. Just make sure that we're not using U anywhere else. And PPID is VPID, yeah. So that should be fine. And that should make that a lot faster already. Now we still are going to be using U, I think, here. And we do fetch the particle here, which is very expensive, obviously. I don't know what MT here is supposed to be doing. Oh, right. This was like some interior attenuation for when a star is emitting itself. It's pretty expensive to... Oh, but we still get this. So just make this E then. Yeah. Okay, so let's try it with lighting again. Let us try with lighting. Com time undeclared. You're so right about that. That is because I did undeclare it. Okay, mdiff undeclared. Type mismatch, 260. Oh. Okay. Frag world pause undeclared. Yeah, this is so messy that I don't even know what is the real one here. I think it is this, to be honest. But we do need Z, and I forget which one was the actual calculation for Z. Yeah, I should have cleaned this up before we did all of this. Okay, it's apparently that. Okay. Yeah, I mean, just... Yeah, we have to go back and redo what I just did because I'm stupid, but whatever. Okay, everything else should just work now. We do have to get rid of U, obviously, and we have to write what I just wrote, right? If length of V color is... Just do. Yeah. Okay, that should be fine. Holy fuck, this is laggy. This is exactly what I was worried about. $124. 124 milliseconds on Intel UHD. Nice. Nice, nice, nice. Nice. I think that if a particle is outside of a certain dist, then we should just not do lighting on it. I think that's what I'm gonna do. We should just make a v-dist. Just have a v-dist, and then based on that distance, then we just determine if it gets lighting or not. So if I mean, that's like a very harsh way of going about doing it, but like there's really no other way that I can think of to do it. v-dist undeclared. You're so right. Holy shit. Seriously? Okay, that's not normal. That is not normal that just happened. That is not a normal amount of time. For one particle. That is not normal. There has to be something in here that is wrong, I think. Let's do no attenuation. Let's just try to, I guess, just... Oh. I think it's this. I mean, is it like faster for me to go like PID? Like, probably not, but like, this also is only happening for 100%. Okay, so now this is way faster. It's just that the math doesn't work now. It wasn't really working before either. Huh. I wonder if that star count is actually the problem. Yeah, it is. What is a star count? Oh, everything might be a star because of our scaling now. Oh, that may be very true. That may be very true. Hold on. Right. That would definitely. So our star threshold was 6. So that's definitely not gonna be correct anymore. Our star threshold should be something like, you know, 1 billion or something, you know. But whatever. Technically our star threshold should be like something like 10 million, right? Based on what our new values are. I totally forgot about that. That would change things. That is going to change things. Yeah, we made everything the same thing. So if we do this, then it would be like 100,000 would be the threshold. Okay. So it actually had nothing to do with the math at all. I mean, it probably, you know, well, it doesn't really help the fact that we have this going on. We don't need to actually, you know, convert that into screen space. We can just use the actual world space center. That should just work fine. So that was unnecessary beforehand. But yeah, the star P count was something like I don't know, like 1,000 something probably, maybe even more than that. Oh, why is this still lagging? Oh. Really? At 10 it's still that laggy? No way. $100,000? 100,000. I wonder why that's not a thing. That should be a thing. It should be passing the star threshold. It should be greater than or equal to the star threshold for sure, without a doubt. I mean, we could make it like 80,000 just to. We can also set this now to not be based on distance. That was obviously, it was just a bug beforehand. Bro, it's just pitch black. We don't have to do this anymore. I don't know why I did that. I'm so confused. The middle particle should have 100,000 as its mass. So okay, it is pretty laggy, but I'm yeah, it's not entirely clear to me why the center like if we just hard code it, does it detect it? Oh, maybe it's I think I get it. I think I get it. I think I get it. Yeah. Yeah, it's actually just the attenuation because now our values are so big that our attenuation is probably fucked. That is probably the problem. Without attenuation, it probably is fine. If I had to guess. Because now everything is so far apart that yeah, exactly. Why is it based on the camera? Why is it based on the camera position? Okay, well that's obviously not correct. Is that why you have to definitely do this? I thought... Oh, I guess it is, huh? Well, I don't want to have to do a matrix multiplication per fragment. That sounds really disgusting, to be honest. Probably pre-compute that for each light source for a frame. And then put that in an SSBO. Okay. Yeah, we should probably try pre-computing that. Yeah, this isn't too bad. This is what it's supposed to be like. What is the frame rate? 60 FPS. 60 FPS. Nice. Nice. Not bad. Not bad. Okay, 60 FPS, not bad. Not bad. Now all of this shit is not good, no. No, it's not good. I wonder if we can recreate what we did here via... I wonder if we can recreate what we ended up doing here via the noise textures, though. Because I like the effect of what it had, but... Oh, and then the U has to get, because of the velocity, has to get loaded in. Oh no. Yeah, that's the pain. That's the pain. Yeah, this was so expensive what we were doing here, by the way. Like, insanely expensive. Like, we probably just, like, crash the computer if I just try this. But we can replicate the same thing by, using, we can replicate the same thing by using noise textures. So that's what I'm gonna try. Color redeclared. Okay. So true. So true, it is redeclared. Managed to eat 30 gigabytes of useless files. Epic win. That is an epic win right there. That is an epic win. Oh yeah. Oh yeah, we can definitely feel it. But look, it looks so good. The planets look so good from up close when you do this stuff. But yeah, you can feel it. The lag. Yeah, we're no longer 60 FPS. And this isn't even with that many particles, so definitely have to yeah. What we can do is bind the textures with the pass. We can bind our noise textures with when we do the draw for it. Okay, things are gonna have to change though with how we sample them, I think, because the frequency and stuff is very different. So yeah, it's not gonna be anywhere near the. We probably have to change the values a whole lot, but for now, yeah, let's just try I don't know if we should really even be doing this in real time, or if we should just be pre-computing textures and doing them. Not really sure, but yeah. Okay, I replaced all of it, and instead of this POW, we should just do alright, let's try that. Yeah, that's what I thought. Yeah, the frequency is just super high. And so it just ends up looking like, you know, like super. You probably have to multiply everything by like 0.0, like so, like really small. We could also just like straight up do why do I have so much upward velocity right now? What the hell was that about? Why does everything look smudged now? Everything looks smudged. Maybe. There appear to be a lot of like artifacts on it. Like in the same kind of pattern. Maybe we just don't need a multiply it times 0.1 at all. Maybe because these maybe because this is already in 0 to 1 space. Yeah, that bug I never fixed. You're not trying to lie? I don't think you're lying. Thank you. I appreciate that. It's like EVE Online. Yeah, I've never played it. I think that this is okay. I mean, it's not like the greatest thing in the world, but it is cheap. This is running 60 FPS, no? Yeah, this is 100% 60 FPS. So, I'm happy with it. These are done in real time. Yeah, I'm honestly I'm not 100% happy with it actually. They just don't look like they look like, before. I think we might have to take a different approach. Like, maybe we just don't. Maybe we try even smaller. Let's try even smaller. Actually made the solar system in C. Yeah, it's. So those are real planets and you can go walk on them? Yeah, that's the goal. I mean, I already have the planet surface, so obviously this is the planet that you're on right now, and then you can go outside of the. So this is us going through the atmosphere, right? But yeah, I just need to make the ability for you to like go on any planet. So that's something that I have to figure out how to do. So yeah, I moved this to 0.01, but obviously this needs to go. Let's try everything at P3. Yeah. Funny that you can make this without killing your PC. Yeah, this is running on Intel UHD 620. Which is Intel integrated graphics in a laptop. So it is made for people that don't have computers like me. The limitations is kind of the whole point of the project, you know? That is the goal. Yeah, it just looks so disgusting. How many octaves was I doing here? I was also doing the F too. I was doing 5 octaves. I had F as well there. Maybe that F matters. Yeah, I will do an article. I have been I put the first of the articles that I've written I put on my website recently. So I'll definitely put an article up on it. I plan on writing a bit. Obviously gonna make a video as well. Yeah, so this is how it is done in this shader. X times F times 4.5 or 2.5, right? Yeah. So let's try that then, to see if it's if it does any different. Our FBM noise texture, by the way, is very small, just for debug purposes. It's 128, which is fairly tiny. That does make things a little bit better, yeah. Yeah, we may have to not only rely on FBM, but also Perlin here to get a more realistic sort of thing going on. So I'm not entirely worried about it, because we haven't put any Perlin in the thing. Now how do I want to put Perlin in here? Honestly, it's kind of a mess. It's kind of a mess. I think warping more could help, to be honest. Maybe we warp with the Perlin texture. All right, peace out. Peace out, Max. Good luck on the IMGUI. Yeah, I don't know. Okay, I'm kind of done with like just recompiling again and again and again just to see it different. I mean, I'll play with it a little bit later and play with it more, but right now we should be focusing on probably something else instead. Yeah, like that looks fine. It's not like, obviously the bands are pretty obnoxious, not gonna lie, but yeah, that looks fine. It looks pretty serviceable. The bands are pretty ridiculous, but who cares? Yeah, and of course when you get close to it, but honestly, you're never gonna be able to get it close to it because then you're gonna start to enter into the planet itself. We aren't moving, are we? No, we are. Very, very slightly. Yeah, very slightly. I wonder why we aren't moving as much as earlier. I think I messed with the mass maybe when we were doing the stars. Dude, like, can you fucking stop, please? I think I messed with the mass when we were doing the stars, but hopefully this works fine. I don't know why. Just for testing purposes, I just want to see if they're all like really close. If I broke something, I just want to know. Yeah, that's what I was worried about. Oh, they are. Yeah, it is gonna implode. It is pretty slow though. And it does feel like it's going to the bottom left instead of the center. Which probably means that I fucked something up pretty bad. Yeah, look at this. Oh yeah, I just went into the... Oh yeah, why is the... well, fuck. Well, I think I broke something now. We need to start rendering the center one again. Yeah, I think we broke it. When I was working on the other shit, probably broke it. Probably broke it when I was, yeah, working on... What? Oh, I see, because we're not even in range of the planet. It's just based on Z value, I see. Yeah, there's a clear bias. There's a clear bias. Yeah, look at that. God fucking damn it. God fucking damn it. I broke something. Shit. Shit. Yeah, well, it's gonna take me a long time to figure out how to fix it. God damn it. Yeah, I had a feeling that I was gonna break something when we were doing this shit. Yeah. Yeah. I'm going to assume that if we read out the buffer, that our mass is probably not correct. I have a readout for this somewhere where I assign the mass. I don't know where it is. I think that this is the correct thing. We just have to figure out where this is. Yeah. No. No, no, no. Okay, so that's our center of masses, so we need the... Yeah, so that's this. It's this. It's actually this, so... that will tell us if our mass is off. I expect to see that our mass is not correct, that we're not building the tree correctly and not propagating the mass to the center correctly, which is probably what's happening. I mean, it's definitely what's happening. Where is our mass? We have to, where's our mass? Yeah, our mass is -6. Our mass is -5. Unless this is incorrect, which I doubt it is. Fuck, dude. I don't want to fucking have to deal with this today. I don't want to have to do this today. Fuck. Fuck, man. We know that it can't be in next. The problem has to be in here where we're actually building it. Where we're actually building the thing. So to prove that this is fine, our depth is always I, so fuck, man. Yeah, I don't know why this wouldn't be working. It's probably some dumb fucking GPU thing with how the state is. So now our comm mass is 20, which is obviously still not correct. I'm very confused why it's not 0 though. Like, why is it not 0? Do you think it's overflowing somehow? Like 400 million is a lot. Let's try that, yeah. Maybe some calculation there is making it go bad. So let's just try really small numbers again. No. Yeah, it should definitely be able to get that. Oh, man. There's no way for me to fix this. This isn't getting triggered at the next depth. Let's just try this. I'm gonna try to brute force it there. Without doing the check for the depth offsets. No. Okay, so let's not atomic add anymore and do that. Let's just cheat it and let's go based on, let's just do that. Let's just cheat it just to prove that this is the problem. Oh, fuck. This isn't gonna work because we need to actually dispatch to maximum nodes every time if we're gonna cheat it like this. Yeah, this is annoying, to say the least. Why would this be happening? I don't know. There's quite a few things that could be going on. Now our mass is exactly 0. Exactly 0. Okay. Okay. Do I set the ready queue to 0? I do. I do. Okay, well this is bothering me, to be honest. This really just ruined my entire fucking day. I hope that it is this, and that it isn't like something deeper that's broken that I didn't notice until now. If it is something deeper that's broken, then I'm just looking in the wrong place. Which would suck. I don't think it is. I don't think it is. Yeah, I don't know. I don't know. I'm just thinking if there's some way that I can check if we're getting to the root. That's what I'm trying to figure out. we can check that, right? We can check that. Let's check that by doing, so let's do comm I equals 100, and then we'll check if we touch the root. That's what I'm going to check right now. I want to check if we touch the root. Actually, this makes a lot of sense, actually, because this is why our... Oh. This is why our main was not taking up any time earlier. That's why. So this makes sense, actually. This has been the whole time. I just didn't notice it. Okay, so we never touched the root. So that's what I wanted to check. We don't touch the root. Let's actually print out more than just this. Let's print out. Let's just make sure that we touch other. Let's print out 400 of them. Let's just print out 400 of the masses to make sure that all of them are 200 or 100. Okay, they're all 0. They're all 0. Interesting. How are they 0? How would they be 0? How would they be 0? Oh. Probably because this. Wait, but don't we set comm here? We set comm to EPM here. Huh. Okay, that's strange. Let's make sure that that gets set up properly. Comm for the first 1500 should be, or 15,000 should definitely not be 0. Like, what? Something clearing it? No, it's just 0. Even though we definitely set it here. Because EPM. We set it here. If I set this, then it'll set it. Is it like some weird driver thing where this is not getting executed? No. Am I doing something stupid? Am I doing something really stupid that I'm not seeing here? Am I doing something dumb? Why did I just do that? I meant to do this. I mean, like, surely that offset is fine. Like, surely, right? And we are mem copying, that is absolutely fine. Oh, wait. Huh. What? I mean, I feel like I'm going to lose my mind here. Tree count should, if I set this up like this, it should literally just put this like full of 100s. I mean, like, what are we doing here? Like, what? Like, what is the fuck? The fuck? The what? What? The fuck are we talking about? Is the map, is the buffer map out? Just silently failing? And it's just not saying anything? Oh my god. Oh my god. Oh my god. Oh my god. Oh my fucking god, bro. What is wrong with me? What is wrong with me? What is wrong with me? What is fucking wrong with me? Holy shit, I'm fucking tilted. What the fuck? Dude. That's fucking embarrassing. Okay, but this is still zeros. Nah, that has to be a fucking joke. That has to be a fucking joke. That's still zeros. What? I mean, now I'm just confused. Oh my god, dude. This doesn't even hit the first 400, so it shouldn't even matter. The first 400 are children, so, or I mean leaves, so it's not, they should just be this. So that's what's confusing, that they're just zero. Like, yeah, am I crazy or like what? I already had one stupid mistake, but like, I I mean, now I'm kind of wondering like if the if the whole SSBO is compromised or some shit. If the layout is just fucked up, I don't know. If like there's padding or something that's happening that I don't know about, I guess. I don't know. There's no reason why this shouldn't work. There's like no reason. There's you know, no reason. Yeah, yeah, I might just like comment out the entire SSBO and then just like test it, I guess. I don't like what the fuck am I supposed to do at this point? I'd like I feel like I've got to be doing something stupid here. I've got to be doing something stupid here. At this point, let's just check other things in the thing. Let's just check. At this point, let's check the ready queue, for example. Let's just do the ready queue. Let's just set the ready queue to 100, and then check that. I like, what the fuck is this? So obviously it's just gonna be 0. This it should be the same. It's just not vec4. It's just UN32T. Okay, so let's just check that I'm not crazy here. And that is a vec4, not an IVec4, right? It is a vec4. That's 100. So I'm not crazy. I'm not crazy. Like, I'm not crazy. There has to be some padding or some shit. There has to be some weird padding thing that's going on here where this is not accessible. I mean, this is like a brutal way about going about it, but I'm just gonna comment everything out other than comm just to prove that I'm not fucking like losing my mind here. And I'm just going to make sure that like that I'm not crazy. Like, what sort of padding bullshit is happening here? Like, I don't know. I'm not splitting this up into multiple SSBOs. You're not gonna make me. But yeah, that's ridiculous. This does not have a problem on NVIDIA, by the way. This is purely an Intel thing. Dude, what the fuck are you talking about? Oh, I didn't do this. Oops. Wait, but this should still have 100 in it, by the way. Should still have 100 in it. Like, I mean, like, okay, yeah, that one was my bad because I didn't comment out the stuff on the other end, but this is very frustrating. Yeah, okay. Okay, let's do a little bit of testing here. Let's only keep the, well, it's actually, it's 100%. It's a padding thing on Intel. I don't know what to say other than it's a really fucking aggravating padding thing on Intel. There's really nothing else to say about it, but yeah. It probably would prefer if we did UVec4s for all of this. But then we wouldn't be able to atomic add, which we need to atomic add this. And we need to atomic add that as well. Here's a question. Is it mad that I just add 1 here? Is that the problem? Is the problem that I add 1 there? Is that the problem? For whatever reason, maybe it's just some shader compilation thing that you can't add 1 inside of the definition. No, you're fucking joking. You're joking. You're so fucking joking right now. You're actually fucking being funny. No, you're being funny. No way you're for real. No way you're for real. Tell me you're Wait, why does this work now? Why does this work now? Why does it work now? Why does it work now? What? What? What are you talking about? What are you talking about? It doesn't work. What the fuck are you... What? What are you talking about? What are you talking about, bro? What are you talking about? I'm not crazy. What the fuck are you talking about? Are you seeing this? What? Wha- uh, why does that one? Why does this cause it? Why does that cause it? Okay, we have to do some testing here. I have to do some testing. We're gonna print out every member of this fucking thing. Because I mean, like, what? Dude, I'm so lost right now. Oh, bro. What are you talking about? How is the, like, what? I just spent like fucking 30-40 minutes on this. What? Okay, yeah, so that's fine. Okay, but then when you put this in, does it shift over? Is that the problem? It shifts over. It shifts over. No, you're fucking joking. What do you mean it shifts over? Why? 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 What do you mean? What do you mean? What are you fucking talking about? What do you mean it shifts over? Okay, I have a question. So let's just okay, so here's what we're gonna do. I'm gonna hard code this to 65. I'm going to hard code these to 65 and see if it does it. I mean, you gotta be fucking kidding me, you know? You gotta be fucking kidding me. Like, what the fuck? What the fuck are you talking about? What type of fucking padding bullshit is happening here? Okay, I have a question. Let's do a UVec4. Let's do a UVec4 for depth offsets. How about that? A UVec4. I'm gonna go fucking ballistic here in a second. Let's go UVec4. Alignment, yeah, this is probably an alignment issue, but it's horseshit because this doesn't happen on NVIDIA. Only Intel integrated graphics, by the way. But it's just horseshit. But we're gonna investigate here and figure out. You motherfucker. You motherfucker. Why? Bro, Vec4, I know about Vec4s and I get it, but these need to be UN32T because we have to atomic add into them, and you cannot atomic add into Vec4s. So that's why these need to be this. Has to be this way. And it's fucking horseshit that this gives me alignment issues. Absolute bullshit just on this architecture. Complete bullshit, by the way. Complete bullshit. Like, Jesus Christ. Isn't it from the 65? It's from MaxF +1. But no, it should not give me. It should not give me. It should not need to be. No, it should not. No. Um. It should not. In STD 430, it should not need to be, at all. Now, will it work with 128? Maybe. But once again, STD 430 should be fine. It should be fine. Just add an array. Yeah, I mean, I could just do that, but I also want the ability to change the max depth. Like, you know, yeah, there are like hacky ways I can change it for sure, but it's like, it's just so stupid. It's really so stupid that it only happens on this architecture. It is really dumb. Really fucking frustrates me. Because, yeah, it worked fine before on NVIDIA. But yeah, it's fucking so frustrates me. Like, yeah, it's fine. But it's like, you know, like if I'm gonna do like this, like, you know, pad 0, you know, like that's fine. I've done this plenty of times before, but it's like, if I ever need to change max depth, then like I need to, so it's just stupid. It's just really stupid. It just frustrates me to no end, this sort of shit. It's so annoying. Oh my god. It's annoying when I like have to sit here and like do this shit. It's just every time it's some bullshit alignment thing, and now I have to change this in every single, you know, occurrence of this goddamn SSBO. It's like, I don't know. You need to pad because your back4 will be 16 by the line. I know, but it's just like, it just annoys me. Because it worked on my other GPU. I don't know if there's like implicit padding that happens there, but yeah, this is like a brand new thing. So it's just annoying. It really pisses me off that I like spent so long here. Like, by the way, like, I had spent so long here trying to figure this out because I thought that it was a logic issue within this shader. Like, I thought that it was a logic issue with how we're doing this ready queue thing. So I, you know, I like did a whole bunch of like things here to like thinking like I broke something, but it's literally just a padding issue. It's always an alignment issue. Like, it always is. But yeah, it's like, it's just annoying because now I have to go and fucking, yeah, this shit's pisses me off, dude. Yeah, I really need like header files, I guess, for like, I need to have some like injection for header files in this project, to be honest, at this point, because of shit like this. But yeah, that pissed me off so much because I thought that I broke something, and so for like 20 minutes I've been sitting here, and then it just turns out that it's an alignment issue just because I changed one thing. Yeah. It assumes 16 byte alignments for vec4 reads. Yeah, that's so much fun. That's so much fun. Yeah, it's actually incredible how much my code does not run on Intel versus NVIDIA. Like, on Intel, like, I legitimately have to jump through so many more hoops than anywhere else. It's truly like incredibly painful. Okay, well, time to like undo everything that I just did here, because apparently it was just an alignment issue. That is so fucking frustrating. I commented out this entire fucking shader, by the way. God, that I don't know, that just got me in a real bad mood. I'm sorry. I don't know. It's not like the first time I've been stuck on something and then it just turns out to be an alignment issue, but in this case, I didn't even change anything within the struct. It was just I didn't test it on Intel. So I just had no clue. But yeah, it was broken for a long time, I guess. I don't need to comment that out. I just need to prove that yeah, let's just make sure that this just gives me hundreds all the way down, and then we'll check it. Yeah, I should have checked the other members of the struct beforehand, because then I would have known that it was an alignment thing. I just thought I was going crazy. Yeah, I should have a thing that tells me which shader that's in, to be honest, but yeah, that's what I thought. Yeah. Yeah. Where? 96. Yo, what's up, Prod? You know, the worst part is that this probably doesn't even work, to be honest. Like, sure, this is probably going to compile, but I still think that it's I think that it still is probably broken on the inside. It just has we just were reading out the wrong values, but our logic is still probably broken. So yeah. Okay, so we have 1000 now, which is correct, and we have 0 for the root. Okay, that's completely fine. God. Oh, man. Okay. Dude, I need to take a chill pill, man. I need to take a chill pill, dude. Okay, that's the Mortons, that's the Bounds. Yep. This is the tree build. And then all of this is the com. Okay, and that's all we're looking at. So when do I plan on releasing this? Is there no release date? Yeah, I don't really have release dates for things, because I'm not like a professional, I guess. So yeah. I don't know. The code will come out when the code comes out, when I finish it, you know? When I stop having to fight tooth and nail with GPU drivers every goddamn day. Okay. 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 Okay, so this works. Oh, you fucking bastard. You bastard. You bastard. Oh my god. Okay, so the mass propagates correctly. Okay, so the mass propagates correctly. So all of this just to figure out that the mass propagates correctly. Ah, fantastic. Okay, so what I'm going to guess is that that wasn't the bug and that we have something else that's the bug. Man, I need to get rid of all of this shit. That's what I'm gonna do after I figure out what's happening here. Okay, so basically what that number means is that the mass propagates back to the root properly. That's what that means. Okay, it's hard to see what's going on, honestly, because we made the masses so incredibly tiny that now everything is like a really tiny dot. It's, so we gotta make it like so that it's not like a tiny little dot. I forget what the numbers were before, and I think it was, no, I remember, it was 10,000 to 100,000. And then the top one was 100,000, and yeah. I just need to see if the behavior of the simulation is incorrect currently. It's biased towards the bottom left, which is what made this made us go down this treacherous path. Yeah, that one flinging out just kind of seems incorrect. Yeah, right there. Yeah. And since the mass propagates back correctly, then it has to be a problem with the next pointers. So it has to be a problem here. So yeah, that was just a bug with us not being able to debug it correctly, but the error still remains here. It has to be the next pointers. It has to be. If D is less than depth, yeah. So this, I mean, this is pretty. There's like no way that could be the bug. We did change it though. let's just see something. Let's just make absolutely sure. Let's just brute force the equation and then see from the brute force if we are if it's a problem with the tree or if it's just a problem with us in general. Just to make sure. I genuinely I doubt that it has anything to do with, you know, the whole thing in general. It's definitely has to do with the tree, but just to prove it for my own brain, let's just make sure that the brute force works properly. Brute force isn't even that slow because we don't even have that many particles right now, so. Yeah, I mean, I kind of wish I could speed this up, to be honest. This is kind of taking fucking forever. I should just, for testing purposes, just make the radius super small. It already is super small, but yeah, I mean, I think that it's proof enough that there aren't things flying around that it's working fine, but yeah, I think that it works fine. It's just the problem is that yeah. Yeah, that's what's supposed to happen. Not really, actually. It's really not supposed to, I mean, just like be stationary. Yeah, that's very strange. That's very strange. I wonder if it's because of the large mass values or something that they stick together. Like if we go back to like having things between 1 and 10. Yeah, why is the brute force not even working? That's kind of concerning. I wonder if it's just because of huge numbers that maybe there's like overflow or something happening. Okay, yeah, we really gotta turn off the fucking lighting. I mean, like, what am I even looking at there? The fuck am I looking at? That's not supposed to happen, obviously. I wonder if somehow the masses are going to 0, but then it would show on the center of mass. Maybe this softening thing may be like way too aggressive for it or something like that. Or maybe Intel doesn't have inverse square root. That might actually be it. If it doesn't have inverse square root, then I'm going to crash out. I'm just like giving a warning here. I'm just gonna like have a moment where I just like get really pissed off. No, it's not that. Okay. If there's some other thing happening here, I'm just gonna be like so confused. We do take in a delta time. We could take a look at that. Maybe somehow the dt goes to 0 somehow. I don't think so. I think it just stays the same no matter what. Yeah, I don't think it's that. Try not running this because it's not necessary. I mean, I'm very confused. I mean, technically, you don't need, if we're brute forcing, you don't need literally anything other than this, which just zeros some stuff. You don't need anything else. Nothing should even touch, since there's no tree that's being computed. So I mean it has to be something to do with God, this piece of shit GPU, like genuinely just fuck you. I don't know, dude. I don't know, dude. I don't like, what do you want from me? Like, what? That's so dumb. Okay, let's figure it out, I guess. Let's make sure that the formula is correct, because we didn't actually take a look at it. It should be the same. Yeah, it should be the same. Oh. 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 Yeah, that's probably why. That is probably why. That is probably why. We're actually laggy. I can't really fucking see anything that's happening. Thanks to us being so far out. It's just kind of awkward because we have this thing where I can just force us to always be outside of the atmosphere. Just for the sake of testing this. I still think it's not correct. It doesn't look correct to me. Combat 0. Oh no, because we don't even fill it, right? Because it's brute forced. Yeah, I mean, if the brute force isn't working, then that's like obviously a big problem. Let's do a test here. Let's just set it plus equals 1 in the x direction, just to make sure that the velocity is integrating properly. No, it's not. It's not. It's not. It's not. Bro, the velocity The position is what? What the fuck? Wait, what? That's the position, by the way. That's the position. Why is it moving but we can't see them move? Wait, what? Wait, what? What are you talking about? Why is it moving but we can't see them move? What? What the fuck? Oh, that's the center of mass. That's not the actual... What? What? PID.vel. PI.vel. See, it starts off moving in that direction, and then it stops. And then it just starts going in a circle. Okay. Like, what am I supposed to do with that information? I don't have to do this, right? I shouldn't have to. That just spawns in particles, but none of that is being done. I guess I have to map out the particles at this point. I'm just gonna map out the particles and then read out, I guess, the positions. Like, I don't know. I don't know what else to do. The center of mass is moving in the same direction. So that means that the particle positions are moving in that direction. The first one is correct, and the rest are not. Okay, let's not... Oh, it might be another padding issue, by the way. It might be another padding issue with us reading it back. Like, I don't know how much I trust this 100%. This is so suspicious, though. The fact that it's just particle 0 has the correct one, and then the rest just don't have the correct, like, what? At this point, I'm just going to just try hard coding it. Okay, so that works. I'm guessing that our mass at some point goes to 0, and so we return out early here. Our mass ends up at 0 somehow for particles. Even though obviously this isn't 0. I can prove it by just doing that. And then we should all go in the same direction. Is there any way that we would, other than greater than body count? Oh, wait a second. Oh, I'm being stupid. We actually do, yeah, so I did. We actually do need the Mortons to get radix sorted, only for the purpose of making all of the EIs available. That's something that I didn't foresee. So I was just being dumb there. I didn't really. Yeah, there we go. Okay, yeah. So I was just being stupid there. Does that mean that this was working fine and I was just being an idiot? Or does it I think that it might have just worked fine, and oh, actually no, it probably wasn't working fine because of the okay, no, it works fine. Okay. It works fine. Okay. So that means it has to be the next pointer. That's the problem. That's what it means. It has to be. So I have to figure out how to fix that now. Okay, has to be the next pointer. Now, no clue how to fix that, to be honest. No clue how to fix that. No clue how to fix that. It would be really lovely if it just like fixed itself. While I set this up again, it would be like awesome if it just fixed itself. I'm using for UI, I'm using nuclear. I'm using nuclear. Okay. Alright, let's try it. It's nuclear. No, yeah. UI doesn't really play well with C. Yeah. It doesn't work. It doesn't work. It doesn't work. Comm mass is coming back 0. So I may have fucked up commenting all this bullshit back in. So obviously, oh yeah, so we weren't building the tree. That's kind of a key part there. Nuclear require bineless texture extension? No. What would make you think that? Nuclear works very well with yeah, the same issue. Nuclear works very well with limited resources. Yeah, same issue. And the mass propagates properly. Okay. So it has to be the next pointer. Well, why am I not giving it depth? Why was I not giving it depth? I'm gonna like fucking hurt somebody. I'm gonna fucking hurt somebody. Holy shit. Are you kidding me? I just wasn't passing a uniform? Okay, I've had enough. I've had enough. I've had enough. Okay. The example required it? Yeah, I mean, the example for SDL2 and OpenGL, I've never had a problem with it. I've just kind of copied their example code and kind of ran with it. And I've never had a problem with it, personally. Yeah. We're just gonna get rid of everything that we don't need anymore. All of it. Because what just happened was fucking the last straw. The last straw. I have backups of all of this. Like, you know, I've backups upon backups. Okay, we don't need it. We really don't. Okay. Yeah, so OpenGL 3 with GLFW? Interesting. Yeah. I use Intel UHD 620 and it's fine, yeah. Yeah, no problem. Okay, so I want to go back to before any of this happened. I was in such a good mood before this happened. Okay. we're just gonna go back to our values from before. Okay, back to our values from before. And yeah, so all of that was because I just was not passing the depth uniform to the shader. Yeah. That's not all right. That one's not all right. There's no attenuation, which is why everything kind of looks weird. Anyway, going back to what I was doing before any of this fucking happened. What was I doing before I realized that the thing doesn't work? I was gonna try to bring together the atmosphere and the not atmosphere together. Also, this should be within the bounds of the selected planet, right? We have to have the planet's position as a thing, not just use that. But yeah, that's the transition, right? So that you're on the planet and then you get off of the atmosphere. Then you're outside. I think that's enough space. Kind of. It kind of feels like things aren't yeah, that's kind of way too close, huh? Things just probably need to be more spaced out. Huh? Okay, so we need to space things out more still. So 50,000 is too close. I thought that 100,000 was a lot, but I guess not. I don't know. I don't know why they're all white. Why are they all white? Oh, because they're all stars? Because they're all stars? Is that why? Maybe I need to change my star threshold then to 1 million then. I probably need to push that up as well, but yeah. Yeah, that's just way too close. Well, the boss says it's going. It's going all right. I kind of had a mental fucking breakdown earlier, but it's all right. Maybe that might actually be the planet that we're on. Actually, that might actually be the one that we're on. So maybe the spacing isn't actually that ridiculous. We might be on that one. I think, yeah. This one is the one that we're on. So that seems all right, actually. Doesn't seem that ridiculous. Yeah, you probably just want to bump it up a little bit more. Yeah, I got pissed off, to be honest, because of I was debugging something and I was not debugging it in a very safe and good manner. And so I was reading garbage data because of alignment, and I didn't really realize it until way later. And so it kind of pissed me off for a while, to be honest, because yeah, that seems good. Now I guess we just have to have the location of the planet needs to be what we're checking the distance to. When we check if we're inside the atmosphere. Right now we just check our Z value, but we need to actually check the planet's center. And so we're gonna use the selected planet thing. What is it? Selected body? What is this use again? Globals.selected body. I have that. Yeah, it's been a long time since I looked at that code. Okay, so we have that. So once a frame, we need to get the body's position, or we can cache it because technically it's not moving when we're on it. But yeah, so we can get it here. It's not that big of a deal to just like do a get buffer sub data just once for one value. It's not like the craziest, like the end of the world. Although we should technically get it when we select a body. Actually, that's what we're gonna do. So when we for introducing, yeah, it was. It's kind of embarrassing. I hate it when I get mad like that, dude, because it's like, it's my fault, you know? Like, it is 100% my fault that that happened. Like, it's just me being stupid and not paying attention and not thinking. Because I should know better. Like, I get it, right? But Yeah. I'm trying to see here where... Oh, we got rid of it. Right, where we select bodies, we want to... When we select bodies, we get the particle data, and we mesh the planet. Oh, right, yeah, doing all of that, yeah. Maybe we just want to do the closest body, but how do we figure out the closest body? That's kind of difficult. I don't really know. How would you walk the LBVH to figure that out? How do you do that? Yeah, that's complicated. Probably not, actually. You just have a compute shader that walks the LBVH and then just checks if the center of mass... Do I want to do that right now, though? Think about that. Do you want to do that right now? Kinda. I kind of want it so that when you just approach planets, you just start to land on them. Like, that's kind of the goal, right? That's kind of the goal. And so to do that, maybe we should just do it with selecting them first, though, because that's a lot of extra logic to write. Yeah, you gotta admit it. Yeah, that's kind of a lot to write. So let's just get rid of all of this. So our selected body is the hover body, right? And so we want to read out into this particle, and then we will cache the location of this Okay, so planet origin 000, we will unfortunately we have to actually do this. So we don't have swizzling. So that's the origin. Good to see me in better spirits. Yeah, thank you. Thanks for hanging out. So our origin gets set to that, and I don't think we need any other information from the particle. We can take the material makeup and then basically generate the planet's surface based on that, but I don't really know how we're gonna do that yet. But okay, so when we click on a body, then we will select it and then select the origin for it, and then that will be our new planet that we will anchor to. And so we actually want to be testing this within planet atmosphere, with a length to that position. It's annoying that I have this way. Uh, I I really regret that I wrote this way in this project, to be honest, because every time I have to write it, I just feel stupider every time. Uh, there. So now, as long as we are 1,000 within the planet origin, then we'll be fine. Okay, let's see if this works. I don't really know. We don't really have the selecting thing a part of the pipeline anymore. Like, I kind of got rid of it when I was working on other stuff, so yeah. It should still work theoretically. Wow, everything else is very, very, very far out. So if I click it, okay, I don't, should have probably done some printing out just to make sure that worked. Globals that hovered body. Where do I get hovered body from? Oh. Oh. Yeah. I do not remember this at all. Whatever this does in here, I have no fucking clue what this does. So I'm just gonna be completely honest with you. I have no clue what that does. Where? Yeah. Okay, so let's just put that there. Yeah, because we draw this here. There has to be a buffer bit, no? Before you read it? We did have a buffer bit, right? GL memory barrier, GL texture fetch, buffer bit. I think that this needs to go here, if I'm being completely honest with you. Okay, let's try this again. I am writing it to, yeah, I do write the ID color to the PPID. The PPID does get written. I did not mean to press that. I did not mean to press that. So that one's on me, but this one's not on me. You're gonna have to buy it yourself. I'm listening to no music right now. It's That's why I'm in kind of a mood. Okay, so let's go over to this body and click on it. Okay, you hate to see it, to be honest. Oh shit. Bro. Oh, it works. Oh, it's just our Z is wonky. Oh, we need to anchor that to the... Oh, it's because our Z is wonky. Our Z and our X and our Y are not relative to the planet. That is so true, actually. You're so true about that. Okay, so where we calculate that X, Y, and Z is actually here. Yeah, so go... So actually, this is going to be minus planet origin dot... Yeah. We're just subtracting the planet origin, nothing fancy. Nothing fancy. Alright, and now we should be able to exist from within the bounds of a planet, within the bounds of a planet, on the planet's surface, in the bounds of the planet's surface, on the surface of the planet, by being on a planet. Exactly what I said. Okay, I'm trying to approach one here. It's kind of difficult, kind of like a needle in a haystack scenario. Okay, we're gonna click it. Yes, yes, and now we have an atmosphere around this planet. Okay, excellent. Kind of excellent, except like it doesn't really... It's not really exactly like the greatest thing in the world, because this does... It does... It does only seem to really work when you're going upwards. When you go to the other sides, it doesn't really seem to work very well. So there's that as well. As the fact that, like, when you're approaching the planet, it's certainly... How are we gonna do this? How are we gonna do this? Maybe our scale is still wrong. I mean, like, our values are pretty massive, right? Like 10,000? No, we need 100,000 for sure. For sure. Maybe that's why it feels off. How the fuck am I gonna do this? How the fuck am I gonna do this? Or what? Also, like, making these, like, massive seems to not be doing anything for the size. Like, 1,000 world units away from them, we still feel, like, pretty far away from the surface. So, I feel like I was actually right about my method of... See, it's the same ratio of distance. What if I hard code these values again? But this should be, you know, if size should be 100,000. Unless the mass just isn't getting through for whatever reason. But yeah, it should come out to about 100,000. Oh, it's massive. Oh, that's massive now. Huh. I already did the math on this though, and that should come out to... Oh, I guess I'm not doing the scale anymore, and I was multiplying it times 500 before. Oh, yeah, that probably... Okay, well, it's kind of hard to test things here, but I think I proved my point. It's just my math was not mathing. But if I standardize it to just this, then it'll just work. Okay, well, that's just too big, unfortunately. Okay, so this is perfect now. So right when you start to get into the planet, then you start to get the atmosphere. Yeah, I'm not sure how we want to deal with like landing on a planet because like as you know, as we know, it's like you've got to land on the ground kind of. So I guess you got to just suspend your disbelief a little bit, I guess. I don't know. It's kind of hard to figure that out. I don't really know. We'll cross that bridge when we get to it, I guess. Although we are kind of getting to it. Something else I wanted to see here. So yeah, let's not do that. Oh, but that's not even... No. I think it's how we calculate our stuff in the first place. It's this divided by the outer radius factor. What if we just inner radius plus all of them? What would that do? Fuck. Yeah, that just looks all wonky, not gonna lie. Also, we have 2 of these. Oh, that's probably why. Not gonna lie. That's probably why, because we have 2 of them, and then we didn't do this one. So that's why. Probably not actually. Inner radius plus. Oh, right, because we start on the surface. Yeah, no, it's actually not. Oh, right, 1,000. 1,000. Okay, we need to fix that. It can't be this in the planet origin. It has to be... I think you gotta get rid of that and then just keep 1,000, because then it's gonna be fully around it. Yeah. That inner radius was tripping us up. But that's because we start at 0. And so we were basically pushing ourselves up to it. So now we're gonna start without the atmosphere. Like if we go here, oh, do we not get anything at all? Really? Oh, because this is 10,000. Oh, so this is, if this is 1,000, that's... So the radius of a planet would have to be 10,000 then, exactly, for this to work. The radius would have to be 10,000 for that to work. We can make this 1,000 and then it would work. Yeah, you want to make it 1,000 for both. It would technically work, I think. Because then the planet is 1,000 and then the atmosphere is right above it. It would be really close what... Yeah, you just saw it for a second there. Yeah. It's just for a second, for a split second. You get it. Yeah, that's the problem. Yeah, so this is it. So we're right on the surface. And then we exit out. Yeah, because at the end of the day, it's 1,000 and not 1,100 or whatever it is for the outer layer. Yeah, so there you go. You see it from the bottom? No. Yeah. If you don't come from the top, then it struggles. Gonna have to figure that out. Like on the top, you get like a nice dome, but from the bottom, it's not great. Okay. Okay. I'm just thinking here. We want to load chunks when we're not if within planet atmosphere, load chunks. So here's the thing. Single argument queue is not specified. What? What is that? What is that variable? What is Q? Oh. I already wrote this. I'm a time traveler. Mesh queue. Oh. It's a timer. So here's the thing. We need to translate those chunks shit. Yeah, that's really difficult actually. Yeah, I didn't really consider that. Okay, so we need to translate our camera position to the planet's position, to the surface of the planet. And so to do that, we need to subtract the center of the planet and add planet radius to it in world space. Yeah. And then make that the origin for everything. Yeah. Okay, here's what we're gonna do. Here's what we're gonna do. We're gonna lock the fuck in. So We're gonna take in. Okay. Why don't I use a debugger? That's rage bait. That is rage bait right there. That's rage bait. Debuggers are for pansies. Yeah. You just add radius. You just literally I think you just add it to Z. I think you just add it to Z. I think I mean yeah, you just add it to Z. Just like keep it simple, stupid, and just add it to Z. We need to put that in the header file. That's what we need to do. We need to put that in the header file. That's the wrong fucking thing, dude. Okay. Okay. I think that should be technically it. I'm just worried about the maybe we should make a function that clears all of our hash tables when we leave a planet. Got clouds? We don't have clouds yet, unfortunately. I was planning on doing clouds today, and then I got sidetracked with a bunch of other shit that needed to get done, but at least it's getting done. And let's just, for now, let's just hard code planet radius to what it needs to be. So we can just have another thing that's just, and we're just gonna hard code it to whatever the real, so it's 1000 right now is planet radius. Okay. So the tricky thing is that we start inside of the Earth at 000. But technically this works anyway. This works anyway because it adds 1000 on top of it. Wait. Yeah, this isn't gonna work. God fucking damn it. where's the creating new mesh? Okay, we're not rendering it because of some reason that I probably commented out the whole goddamn thing. I probably commented out the pass for that while I was doing things. If within planet atmosphere, we are within the planet atmosphere, 100%. We are within the planet atmosphere. And we were making meshes. So why were we not rendering the thingamajiggy? Made an entire universe? I mean, I guess so. I really think that the more impressive stuff is the stuff that happens on the ground, to be honest. The terrain stuff is pretty cool. Dude, why is this not rendering anything? Why is this not rendering anything? Actually, so this is a good thing. Let's just go to our, okay, I don't know why I just went all the way around, but let's just go here and then just get rid of this just so that we okay, there we go. Okay, so we're not crazy. We're not crazy. Does it extend outside of the planet? That's what I want to know. No, because we're not within planet atmosphere. Okay, so that's good. So once we go outside, we stop rendering. Okay, so that's completely fine. That's absolutely fine. So we need to be up there is the problem. Okay, so that's the problem. We need to be up there. So we want to subtract the planet radius and not add it. We want to subtract the planet radius. That's the correct thing. Where is the mesh? Sir, where is the mesh? I mean, to be honest, it's hard to see it with the planet underneath me. If there is a mesh. Oh, I just saw it underneath me. I think it's getting occluded by the planet, yeah. Yeah, it 100% is. Yeah. Okay, well, that just makes me feel like it's at the bottom, actually. Okay, we should probably just stop drawing the selected planet again. That's what we should do, because it's getting to that point where we should have to do that. ID equals 0. I just want to see what's going on. Why is there an entire solar system? There actually always was. You just came along after we made the planet stuff, while we were making the planet stuff. But it actually started as a space simulation. So it first started as a universe. It's just then we started doing the planet stuff. So yeah, I mean, to be honest, I kind of lost where the fucking planet was. Yeah, it's pretty cool. If you want to see them collide, I can make them collide and stuff. Baymax says she hates you. Sorry. Okay. I'm going to take it on the chin and not say that she has a stupid name. Oh no. Oh no. I'm just kidding. 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 You're frying the entire... I'm not gonna say that. I'm not gonna say whatever the fuck that is, but yeah. I believe it. I think I've realized the problem. I think it's because I'm wearing a sweater on a summer day. I like woke up cold. See, the problem is that there's so many, that they're so big because we made them massive, that now it looks kind of goofy. That's kind of the problem. It kind of looks goofy because we made all of them the same size. So I do kind of look like an idiot here. I know 100%, like I am an idiot here, but yeah. Are you doing procedural generation? Yeah. Honestly, it looks a lot cooler when we don't have any stars. Yeah. So technically just the big bodies become stars, but right now we're kind of just like trying to get the numbers correct because I want to get it so that everything has a correct... Yeah, so this is the size that everything is supposed to be. So you can't see it right now, but the center thing is the only star. And that's why everything is like lit up like it is. Now there's like a bunch of different stars. And there's no attenuation, so everything just starts to get like really lit up perfectly. But yeah, eventually the simulation just collapses if you have things close like this. Like I moved everything close to kind of show off how the dynamics work with gravity and stuff. And so we're going to see everything just collapse towards the center in a second here. They're going to kiss. Oh my god. Yeah, so basically, the bodies absorb one another. The bigger ones just kind of eat the others. As you can see, when they graze each other, they lose some of their mass into the bigger bodies, which is kind of how the dynamics work in real life, but here it's obviously done a little bit more goofily. I actually do have the ability to have bodies shoot off other bodies, depending on what happens, like if they hit at a certain angle or whatever. It is gonna lag. Yeah, it is gonna lag because we are on the Intel GPU. So yeah, when things start to get close, then Yeah, that's unfortunate. That's unfortunate. Yeah, that's a bummer. The Big Bang is about to happen. Yeah, it's calculating. I'm hoping that it pulls through eventually and stops lagging so much because I want to see it happen. Because I haven't seen this in a long time. Okay, I think the problem is probably that, yeah, okay, there we go. The GPU just overheats for a little bit and then it's fine again. Maybe my GPU will blow up first. Yeah, it's Intel integrated graphics, so it isn't like the greatest thing of all time. I should have ran this on the NVIDIA GPU just to like show off or whatever, but okay, that's actually what I'm going to do because this is like embarrassing me, and so I don't want to be embarrassed anymore. Oh my god, this is even slower with the NVIDIA GPU. What the fuck? Wait, why? Okay, well, never mind, I guess. We're closed for business. I don't know. What the fuck is that about? Well, whatever. That's a bummer. I don't know why that's being like that. It might actually be just the lighting. Because I may have just like not done that, to be honest. I wonder if it's just the lighting. Because I did have the ability to like, you know, have a lot of stars. So it may have just been that there were a lot of stars at some point. Yeah, my computer is not enjoying this one bit. I'm not gonna lie. It's not enjoying this one bit. Okay, now there's only one star, so... So the flashing that you're seeing is that it can't choose which one is the one star. That is kind of the problem with doing this. Also, there isn't a lot of softening on the gravity equation anymore in relation to the mass. So they can only take light from one star at a time. No. I just turned it to one star mode because I wanted to see if it could not be a laggy piece of shit. Okay, it's still going to be a laggy piece of shit. Okay, well that's a bummer, to be honest. Yeah, at that point I don't think it's the lighting actually. It is the rendering though. But yeah. I don't think it is the lighting. But yeah, they can take obviously up to as many stars as you want, but will it be fast? Will it render fast? Absolutely not. But yeah, I have like a maximum of like 6 stars. But yeah. Maximum of 6 stars. Actually, I think it is just the lighting. Yeah. This renders so much faster. Yeah, this is just like incredibly fast. I guess planets and stars are going to be further apart. Yeah, yeah. I'm just doing this just to show off what the dynamics between the bodies look like. When everything is far apart, nothing happens basically, you know? So it's a lot slower and more boring. But obviously when you have things closer, then a lot of cool shit starts happening. Like I like watching the slingshotting. It's pretty cool. And it's cool because you can start to see like solar systems form. Of course, you would have solar systems alive for a lot longer if you have, you know, a lot more space. So you can see like systems like this start to form. Oh yeah, it does start to really take a toll. I have to go back and profile, I guess, on why it starts to freak out. Oh, I think it might be because yeah. I think I have some idea why, but if I had to guess, it's actually because we have unbounded space. So that means that if a particle goes way, way out, we have no way of cutting that particle off. So technically the Morton tree could just become totally collapsed because we don't have a way to clamp it. I got rid of the clamping when I was debugging something, so that might be why it has these lag spikes, because the tree might actually just collapse at some point. Yeah. Yeah, I really have to profile whatever. I want to see what's the longest you've let it run? I've let it run a long, long time with a lot more particles than this. On the NVIDIA GPU, we can get pretty far with a lot of particles. On the NVIDIA GPU, it's technically should be able to run for like, yeah, 300 is insane. On the NVIDIA GPU, it's technically can do like 500,000, but then the GPU overheats. On the Intel GPU, it's definitely not as strong. But yeah. Yeah, that's crazy. I have to check out the Yeah, that's a bummer. Because I just got done. Oh yeah, we're overheated right now. That's the problem. That is the problem. Actually, let's go and see NVTop right now. Oh, we're actually so fine. So I have no clue why this is so laggy. That's 200. Okay, well, we have to do some, I have to do some investigating now. Yeah. Because I hadn't tried the NVIDIA GPU in a while. The good thing is that the NVIDIA GPU I can I can do these queries on it, which are pretty easy to profile. I was just in the middle of working on something, so that is kind of a bummer. I got rid of these earlier, which is why you don't see them there, but and we have the end. We want to GL time elapsed, and so now we just have to collect them at the bottom here, and then that should tell us something. Does this tell us anything? No. The NVIDIA GPU, it should. Okay, so what? Main is 100 milliseconds. Oh my god. Oh my god. Are we brute forcing? Did I not get rid of the brute force? No, I did get rid of the brute force. Huh. Okay, I have to test this. It may crash my computer though. If I uncomment out that line, I wonder if we crash. I mean, it will crash my computer if I uncomment out this line and we break out. I just want to make sure that I think we're fine to crash. I'm just making sure that I'm not going to lose anything that I need. But yeah. I'm 99% sure that it's the tree is incorrect, and we have a an incomplete tree. Somehow. Okay, let's not do that actually. We don't have to do that. We can figure that out a different way. I don't want to have to restart the computer. But yeah. It infinite loops if I comment that out if what's happening is happening. Do I really want to map the buffer out again? That might be what we need to do. Yeah. God, God, I have no life, by the way. Like, how do I know how to write that? Like, how many times have I written that, by the way? Like, what the hell is wrong with me? Okay. Let's see. Let's see what the mass is. Oh, fuck. Fuck. I forgot to unmap the buffer. Oh, I forgot to actually copy in from the pointer. Also. Some very unsafe code. Love it. I think that this is the correct, it's this. Yeah, there we go. Okay, there we go. We made it legal code. We made it legal code, that's right. Okay, so the M is correct. Alright. So... yeah. So this can't... So this isn't correct. This is not correct. The next is not correct. Fuck. Well, we may have to crash the computer. To be honest, we may have to crash the computer. I think it's time to crash it. I think it's time to crash it. So basically what I'm doing here is I'm thinking, so this has to be done from the leaves up into in order, right? And then this has to be done from the top down. So it's the opposite direction, which is why it goes in this order. There's just no way for me to actually check if it's broken, but I think it is broken. I think it is broken. The only way for me to check would be to actually, you know what, that's what I can do. That's what I can do. If we break out early, then let's just like prove it by writing that we will set comm at body count to 0, and then when we read it out, we'll get 0. That will be the test. Implicit cast, yes, because it's not a W. You gotta put a W there, buddy. What are you doing, dummy? You gotta put a W. Bro. That's not what I expected. That is not what I expected. Am I sure that I'm doing that right? I think I am. Okay, here's another way we can check for it. We could just crash the computer. I think we might have to. I mean, I just gave it a check and it says that it's fine. It says that it's fine. We aren't hitting this, apparently. According to this, we are not hitting this. Oh, why are these not in here, brother? Why are they not in there? Why are they not in there? Huh? What? Why were they not in there? Okay. Okay, now I'm convinced that it had something to do with that. Nothing else is fucked up here, right? No, nothing else is fucked up there. Huh. Okay. Well, now I don't know. Now I don't know at all. God, I thought that I had it there for a second. Because that was obviously incorrect. But now it's not the thing. Okay, so if we're not hitting this breakpoint, then it's fine for me to remove it, right? 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 If I remove it, then we're still fine, right? Come on. Come on, do it. Do the crash thing. Come on, crash the computer. Come on, do the thing, man. Do the thing. It isn't crashing. You were supposed to do the thing. Wait, what? What? Okay, here's a good question. What if it's one of these? We didn't actually think about this. That's a good question. Wait, what if it's one of those? Can you hear the computer now? Yeah, I thought it was gonna happen, but it didn't happen. I was taking all the precautions. Okay, so it still is broken. Okay. Here's a question. Is it 100% main? Yeah, the computer is kind of pissed right now. The computer is kind of pissed right now. Not gonna lie. Not gonna lie. Okay, here's something. Let's get rid of the atomic exchange bullshit. Let's just keep it super simple, right? Okay, I'm waiting for it to shut up. Are you gonna stop, please? So that we can test this? I need to test my theory. Come on. Come on, man. Okay. I mean, it says it's 45. It doesn't sound like it's 45. Actually, I think that my computer is broken. Actually, I think that the problem is that my computer is broken. Yeah, I think that my computer is broken. I think I broke my computer. The fan is permanently on, even though the GPU is at 44 degrees Celsius. Okay, it just stopped now. I think we might have to give this one just a little bit of a restart. Like, why is that 100 milliseconds? Like, bro? Maybe it's like I was saying earlier, and we need to clamp again. Maybe we need to clamp again, just with like larger values, since we have larger values. Just need a clamp again. Or else the tree breaks. Yo, what's up, Francis? I'm going through a bit of pain today. Today has been quite a painful day. Because I'm going back to the space part of the simulation, and I'm realizing just how much of it I don't remember how it works. And so we're going back and we're trying to figure out why things are broken. This works, believe it or not, fine on Intel, but not fine on NVIDIA, which is what we're trying to figure out right now. Unless me inserting this padding is a problem somehow. I don't know what I changed, really. Like, I didn't really change much. Oh. 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 Do you think it's that? I mean, that could certainly do a thing. But then again, the mass was propagated to the start correctly, so yeah, I mean, why is it so suck? Like, it's actually making my computer like cry right now. It's like my computer is like dude, fucking stop, please. It's like crying out for help. No, it's definitely not something in here. It has to be how we set up the... Actually, here's the test. This is the test that I was going to do beforehand. I want to test if it's actually faster for us to brute force. I want to see if it's faster if we brute force. That'll be the real test. All right, I have to check. I'm an addict. I have to check. No, nothing. No emails for you, mister. No emails. No emails. Okay, it isn't faster. Really? It isn't faster for... I mean, maybe now that my computer is freaking out, but... My computer just froze. Yeah, it's done. Yeah. I feel like... Alright, buddy. Take a nap. Take a breather. Brute force what? We have an equation. We have an equation for figuring out how gravity works in the system, right? And so brute force just means that we do each particle against itself instead of doing a tree walk for a bounding volume hierarchy. Okay, we killed the computer. It needed to die. Okay, so I just typed helix into this. So here's the thing. It's not telling us that that anything is wrong. Obviously there is something very wrong here. There's definitely something very wrong here. Here's the thing. We don't have to actually do any of this if we're brute forcing. If we're brute forcing, then we can just do this. We just do this. All we need to do is the radix, and the radix stuff should work 100%. There should be no doubt about it. I think you study a lot of physics. I mean, I guess, man. I just looked it up on the internet, to be honest. A lot of people have done stuff like this, so I just kind of am piggybacking off of their success. Bro, it works fine now. Okay. So let's do a few things here. So let's just one thing at a time. Let's just bring in the tree and the com. The com cube. Okay. And let's bring in the com and the next. Brother, so what you're telling me is that there was no bug. My GPU was just broken. Okay, well, that's cool. Well, you're not broken anymore, so let's just... Okay, so I broke my GPU so bad that I just had to crash my computer until it fixed itself. So once again, not a problem with the code, but with the hardware itself. Probably my code pushing the hardware to that point might have, like, I feel a bit bad about it, but you know, at the end of the day, you gotta do what you gotta do. What's up, Egg Lover? I hope you're doing well. Okay. Okay, never mind. Okay, never mind. Never mind. Never mind. Never mind. I take it back. It's absolutely a massive problem. We have a massive problem on our hands. We have a massive problem on our hands. Why are we overheating that fast? We should really not be overheating that fast. That's kind of insane for us to overheat that fast on a 15,000 particles. That's kind of insane. I think there might be something wrong with my NVIDIA GPU on this thing. I think there might be a problem with it. I mean, to be honest, this laptop does kind of suck, but I mean, kind of is kind of putting it in like a really generous light, but yeah, I'm a generous guy. Yeah, this is untenable. This is absolutely untenable. Absolutely untenable. So why? Okay. So it's guaranteed to be the tree now. It's guaranteed to be the tree. It's guaranteed. It's guaranteed. It's guaranteed. Okay, so we don't have a problem. It's the tree. It's the tree, 100%. It's the tree, 100%. Okay. That just proved it. So the brute force works fine. The brute force works fine. It's the tree. It is the tree. It is the tree. I don't remember what this does at all. I mean, this does our depth, right? So we take the left child depth and then the right child depth, and then we get the depth for us, which makes sense. This I did change. I wonder if we really want to stick with this depth offsets thing, or if we just want to go back to doing this. If we go back to doing this, then It's probably a lot safer for debugging and stuff. The problem is that I'm just going to keep on crashing my computer until we get it right, is kind of the problem. The good thing is that we have this here, which is supposed to be helping us out. I don't think it is. This is just a failsafe, so that if we get stuck in an infinite loop, then we exit out. I don't think that we are triggering it though somehow. I think that we're just broken otherwise. But that's alright. That is alright. Okay, let's try this out again. But with this ready queue ID system that's you know, in a less precarious way. Okay. Does it just work, or is it not working? I'm gonna put my money on not working. Yeah, the mass is 0, so we didn't propagate back to the root. So that's the problem. That would be the problem. The ready queue of the parent equals 0. Okay. Do we set the ready queue to 0 in tree count? Do we do that? We do. We set it all to 0. The thing is, all of this stuff is kind of old code, so it doesn't make sense that it would just like break now. Doesn't make sense. Doesn't make sense that it would break now. Why would this not work? Why would this, how would this not work? There definitely isn't some funky alignment thing anymore. I think it Yeah, I mean, I don't know why that wouldn't work. I mean, if we're doing this, then we don't have to do this anymore. We can just quite literally start with all of the things at 0 at and just start it like that, but it's probably something stupid that I'm not thinking of properly. Yeah, I'm not sure. Then again, like, if this works, then there should be, like, if this works, then... Oh, wait a second. This did work fine. I'm just being stupid. I'm not thinking, this is... Obviously, this I doesn't make any sense. It's supposed to be... If you're doing this, then it's uint I equals ID. That was just me being dumb. If I had to guess, this is not gonna work either. Still not. Really. How come? How come? How come? In all of my optimization to make this faster, I apparently just broke the code. So that's probably not great. Okay, there we go. So as soon as we get it working again, it what was it that... Is me bringing that back or setting this to 0? Yeah, as soon as we get that working again, now it breaks again, so that obviously is not good. Yeah, it's gotta be next then. Oh, 999. What is nmax.w? Max and nex. Max and depth. Oh no, depth can be sentinel to 999. Depth can be sentinel to 999. Something is ending up with the wrong depth value. I wish that we could have asserts in here. Like, you can cheat it, but it would be really nice to have an assert here that's like assert depth, or assert our nmax depth is 0. So that's really what we want to see. But really we don't have any idea here. Yeah, the key to understanding this is that this is all old code, and so it worked beforehand. It's something to do with this happening on every depth and not just the depths closer to 0. Has to do with that. I wish I knew what the tree looked like, but trying to piece that together is kind of difficult. We would have to read out Q out again, and that just gets super messy. Oh, here's what we can do. We can actually map the buffer out for the for depth offsets. That's what we can do. We can map that buffer out. We actually already have that as a thing, so we can just yeah, you can't do. Depth offsets. Okay. Okay. Let's see what that gives us. That should give us something substantial, because that will tell us what the layout of each depth is. Oh, wait, but yeah, we need to actually write it out, because we aren't doing that currently. So we have to temporarily go back to this way of calculating things. The way that we did it in the beginning. We know that that wasn't the bug anyway, so it doesn't matter. But yeah, that will populate this with depth offsets so that we can see what the tree looks like. Okay. I see. I see. I see what's happening. Okay, well, I'm just stupid. I'm just really stupid. We have to obviously put, when we upload the buffer to the first place with zeros, I got rid of something when I shouldn't have gotten rid of it earlier. When we upload it to you have to put depth offsets 0 equals body count. I got rid of that line, not thinking twice about it. And that's a very important line. Okay, but this is still broken. Oh yeah, because this depth offset actually doesn't do anything. This doesn't actually mean anything. But the fact that it's all, yeah, the fact that it's all power of 2 is like kinda, yeah. I have a question. What if it's radix actually? What if it was that radix thing? Oh, that's the old radix. What if it's radix? No. No. $50,000 should definitely be a fine amount. I don't think that mass has anything to do with it. Like big mass numbers shouldn't have anything to do with it. Biker gang, by the way, it's like 30 bikers on motorcycles just went by. It's like crazy. Never seen anything like that. Absolutely bizarre. The only other thing that we changed was the number of work groups. Which I don't see how 128 work groups would change anything, but you know, who knows, I guess. We didn't change anything here, right? We have 128. We have 128. So we set that properly. Hey, what's up, Arya? Are the clouds going? They didn't go at all. I'm not gonna lie. It's a total bait, the cloud title. I was gonna do clouds today, and then I decided, hey, let's figure out why nothing fucking works anymore. And then I decided to figure out why nothing fucking works anymore. No, so the problem is that when I get something to work on NVIDIA, it no longer works on Intel. And then I refactor the code so that it works on Intel, and then it breaks on NVIDIA. And then it's just back and forth, and back and forth, and back and forth. Until, like, you know, until I die. That's what's gonna happen. I'm gonna die. That's what I feel like at this point. Yeah, I don't know. Yeah, I mean, okay, so I mean, we could test if the Mortons are sorted on NVIDIA. The Mortons should be sorted. It would make sense if they're sorted, but we could check if they're sorted. We could map the Mortons out. But yeah. Oh, there's no offset for this. You're so right. Alright, I'm just gonna drop the Mortons out. Oh, yeah, e dot entry I dot m. Alright, so let's see the Mortons. Let's see if the Mortons are sorted. If the Mortons aren't sorted on NVIDIA, then that would make sense why nothing works, but I kind of doubt it. I think that they probably are sorted. They are 0. Okay, let's not freak out yet. Let's try and think about this. Oh, yeah, I didn't fucking bind the buffer. Duh. What the fuck am I thinking? Yeah, that would do it. That would do it. I'm taking this jacket off. I'm taking the jacket off. It's getting serious. Okay, the Mortons are actually still 0. After we bound the buffer. So that's probably... Hold on. Did I bind this correctly? Okay, so let's lock in here for a second. Morton data 100%. Yeah, it has entry to body count. So we should 100% have Mortons. Okay, here's a test. Here's a test. Let's try and get rid of the radix completely, and then see if we have Mortons on the other end. I'm guessing that the radix is deleting the Mortons. No. No, they're just 0. They are just 0. They are just 0. What? Okay, let's try something here. Let's try inside of tree count. Let's try actually breaking the Mortons. Let's just send entry ID equals 100 and then see if this comes out on the other side. I need to know if I'm mapping the buffer correctly or if I mapped it incorrectly. I may have mapped it incorrectly. Yeah, I get it. This is .m, right? I called it? No, I called it Morton. Okie dokie. Okie dokie, okie dokie. Okay, so we may have a problem. We may have a big problem. There may be a massive problem. There may be a massive problem. There may be a massive problem. All of the Mortons are 0. Uh, when we were fucking with the bounds earlier, did we fuck with the bounds so bad that it broke everything? Is that possible? We got rid of the barriers. Oh my god, I got rid of the barriers because we were fucking around with it. Oh my god. Bro. Oh my god, I'm so pissed off. Oh my god, I'm pissed off. We aren't serious, dude. We aren't serious. We can't be for real, dude. Okay, okay, okay. Alright. Alright, we're turning the radix back to where it was at, and yeah. Okay. Yeah, so basically what all that was about was that I earlier today I was fucking around with the code in a way that I probably shouldn't have been, and just got rid of the barriers in the bounds prefix. So the bounds were just coming back as 0. So the min and the max were both 0, which made all of the Mortons 0, which therefore collapsed the entire tree to 0. And so that's why the whole simulation was broken, was because of that. So that does suck for sure. We are still slow, don't get me wrong. But I think it's because my GPU is overheating right now. I think if it wasn't, we'd probably be fine. Yeah, that sucks. That does suck. That does really, really, really put a damper on things, huh? Okay, well, I'm going to put these values back to what they were. This is supposed to be 1 million or 10 million. I can't remember what we had it at. I think 1 million is correct. Yeah. Okay, now that my computer isn't overheating, I want to see the performance. Finally, we can actually do some checking on the performance. Oh, look how fast it is. Yes. Okay, well, to whoever was here from earlier, that's what it's supposed to look like. That's what the simulation is supposed to look like. There you go. It only took me crashing my computer multiple times to make it work. Multiple times. Yeah. Okay, what was I working on? Oh right, I was working on getting the atmosphere to work. When we're I was getting the ground to work. Right. How do I get that working again? Oh right, we have only one light source. Right. Right, yeah. Yeah, that's pretty disorienting. Epilepsy warning? Anyone? And then the GPU overheats like this. Lovely, lovely. Yep, that's the pain of having my GPU, is that it runs so fast, and then it hits a wall, and then it starts overheating. So that's the pain. That is the pain. Runs great though. Would probably run great on a good computer. Anyway, so back to what I was doing. Yeah, so why is this not rendering in the first place? Oh, right, because we were having trouble with the... I can't remember. I can't remember what we were doing. No. I don't think that we want to do this. I think that we want to do it based on Z, because really we're never going to be like actually spherical with a planet's surface, I think. Or at least for right now. So let's just define this as our Z. Let's just fabzef. No, let's just do yeah. So 1,000? I think so. So where's the ground again? That's a good question. Where's the ground again? Where is the ground? I put it at, we were subtracting the planet origin and the planet radius. So if we're subtracting planet radius, yeah, then we would just have to be at the top. So that should work already. That should work already. That should work already. And you can see it there. Then it disappears. Oh, you can see the ground there. It's just rendered below everything else. It's rendered below the atmosphere. Or something like that. You can see it there. That's the silhouette of it. We're gonna collide with it here. Yeah, at Z0, we okay. So why are we rendering it below everything? That is now the question. If we are rendering it, then why is it below everything else? What if we don't draw that? What if we don't draw that? I just want to see what's occluding it. I think that it's that. I don't think it's the atmosphere. I think that it's the sphere itself, but that we aren't removing it from the depth buffer enough. Ah, dude, I have to... Huh. Maybe it is the atmosphere. Oh, no it isn't. No it isn't, no it isn't, no it isn't. No, it's... Oh, we're... Okay. So, hold on. We are... Okay, so I'm thinking of this wrong. We aren't... Actually, yeah, that should work. If we're subtracting the planet radius, then that should mean that when we're at the top, then we are 1,000 down, right? So that should work. That should absolutely work. That should work, like logically. But the ground is permanently below us, which I suppose makes sense. But if you subtract the planet radius, then that doesn't work? Why? Maybe it would be good to visualize it somehow. Visualize planet radius versus... It's finding that as 0, 0. It's the problem. So it might actually not be a problem with that. It might be a problem with... Oh, that's probably... Wait, no, but then... That would still be... Oh, this is so complicated because we're trying to... Because our noise function obviously wants it to be at 0, 0. But now our planets have arbitrary space. So now we need to transform all of it to 0, 0. And so that's what I'm trying to figure out how to do. I thought that if the... Yeah, but the camera position doesn't actually mean anything. That's the problem. That is the problem. The camera position doesn't mean anything. It's the actual chunk positions. It's not the chunk positions. It's when we generate the chunks. Well, it actually is the chunk positions. Yeah, the thing. Oh, okay. So here's the thing. Just because we say that we're here, we don't actually translate it up to the player. Yeah. So we do actually render this the proper place. We just don't translate it upwards to the player. That's the difficult part. How do the you'd basically have to add planet radius to everything. We have to add planet radius to everything. And then when we're doing collision, then we subtract planet radius from the position. That's really annoying, to be honest. That is really annoying, but that might have to be like what we do. Since everything is centered around 0, we may have to move everything by planet radius in the end. We can do it on the end though. We don't have to do it in the beginning. We can just do it when we actually draw the meshes. When we draw the meshes, we can just draw them and add planet radius to it. We can just like take in a uniform for it, and that's just it. It's really that simple, actually. You need to unfortunately do it for the water too. And it just literally, every vertex just gets shifted up by U planet radius. Which isn't very intuitive, to be honest, but that is what it's going to be. Okay, clearly this works now. Okay, I'm trying to figure out where this needs to go here. I'm just gonna put it here. Where else was it? It was in shadow dot vert. We want to oh. U planet radius, absolutely. Okay, and then our final one is going to be in the water vert. So this one might be a bit tricky. let's not get confused here. So we just need to go pos.z plus equals u planet radius. Let's not get confused here. It's not complicated. Okay. So now we've just added u planet radius to everything, which should solve our problem. Now, we won't have collision until we figure that out. We have to take in planet radius into our collision function and then shift everything upwards to us by planet radius when we're checking for collisions, which is very confusing. That's very confusing. When we calc density, we might have to shift us down. We might have to shift us down. Yeah, that's super fucking confusing. So okay, definitely not going to be any unforeseen consequences for what we're doing here. Definitely not. Okay, now if I did all of that correctly, with our z at 1000, we should be able to stand on ground. I had to shift everything downward and shift everything upward in a really janky, shitty way. And as you can see, now we're in heaven, apparently. Okay, so this is, see, I don't know why we're in heaven. Also don't know why are we offset? Oh, this is gonna be a classic one, isn't it? This is gonna be the classic dustmite. This is gonna be a classic. Like, what the fuck are we talking about? Why is it offset? And why is it bright? The collision worked, which was what I cared about. As long as the collision works. Well, not as long as the collision works. I mean, I kind of want everything to work as well. Kind of want everything to work. Yeah, why would this... Okay, let's try... we kind of can't get rid of that now. We kind of can't. Okay. Let's think. There's a few things that could be going wrong here. There's a few things. Okay. Oh no, but the cam pause is... We always do it between cam pause, not Let's print out the cam pause. Need to know it. I need to know if it's aligned. Because for whatever reason, the... I don't know why it isn't textured. Is interesting. Also, it is super bumpy. It's another thing. Yeah, we're never hitting the ground. So there may be some things with our collision that... So this seems to be working now. Ish. Get her. let's get rid of a couple of these checks, I guess. Just for now. Like this one. Let's go and look at this. Why would this, us changing the pause here? Oh, it probably has something to do with this, us doing this V color. Yeah, it probably, yeah, it goes. It probably just becomes white, huh? Okay, well, while we're working on this, let's just get rid of the V color and just do the ADIF, yeah. Just for now. And working on the camera, also my computer freaking out means that we should probably just move this to here again. And in the camera, we need to figure out why this is bumpy. Why would it be bumpy? Why would we not be hitting the ground? Well, obviously it might have something to do with the fact that we shifted everything down by planet fucking radius, but that's neither here nor there. Where's P? Oh, P is proposed. Alright, there we go. Basically, I have this thing with the meshes where it gets to be like snow-capped mountains when it's higher in Z. However, that's obviously pretty treacherous when now we are 1,000 units up. So, yeah. Alright, so I'm not sure what that's about. Okay, so we're still not hitting the ground. We're still not hitting the ground. Also, I'm pretty sure that this is all LOD at the wrong LOD. Oh, it's not within frustum because we have to build our view matrix that is upwards. Okay, well this now gets to be a bit complicated. We have to build a fake view matrix. Okay, so how do we do that? We need a fake view matrix. Okay. We're gonna take in planet radius. And fuck it, we're taking it. No, we're not. We're not. Okay. And now we need to do this. Passing camera to parameter of incompatible type camera. I don't think that we actually used the cam in here. Yeah. No. Yeah, but it doesn't matter. Yeah, we're fine. Are we fine? Hold on a second. Hey, what's up, Shark? Are we fine? Let me... Yeah. Maybe. Maybe we're fine. I think we may not be, but that's alright. We're gonna figure it out. Okay, let's go here, here. We can fix that in a second. Right, it's, yeah. Okay. Okay. Okay, let's go and test that. Because now we're making a fake view matrix so that now the ground should always be within frustum when it's actually within frustum, instead of it using the translated 1,000 units down version. Yes. No. No, yeah, it is still wonky. It is still wonky. Also, we still don't hit the ground, but yeah, see, it's off by a little bit. It is ever so slightly off. Okay. Yeah. I'm just gonna try something here, which is just we're just going to basically compute the bases from scratch. I'm just gonna call update camera on it. I'm just gonna call update camera on it and then see. And then use that view matrix. I just wanted to avoid it, but we may not be able to avoid it. I think that maybe you have to compute the entire basis from scratch. I don't know. Fuck. Do I play guitar? I do. I do. But like not like, you know. It's not like one of these things where it's like, oh yeah, I play guitar, I play like covers of songs all the time, and I like, you know. No, I play my own songs. That's how I play guitar. You know. People ask me all the time, oh, did I learn guitar? I just play the instrument. I don't know. Okay, it works. That works. That works. That completely works. Okay, so the issue now becomes that the ground is not working. We never hit the ground. Oh, we never hit the ground. Aha. See, talking out loud, I just said the answer. The answer is that we never hit the ground. The disk to floor is RZ to the ground. However, RZ needs to be adjusted. So hit ground is final.z minus planet radius. That's what it is. Or you could do current floor minus planet radius. But oh no, current floor already has planet radius baked into it. That's kind of the problem, actually. That is the problem, actually. We should make it so that we spawn on the ground. That would be pretty cool, actually. Nice. 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 Just hopping around, just doing a bit of bee hop, huh? What do you know about that bee hop? What do you know about that bee hop Lego 2? Huh? Okay, cool. Cool. I think my problem is that I don't know when to ask for help. That's why it gets stuck for too long. I mean, pretty fair. I mean, when I get like bad stuck, like stuck, that boy is stuck. I mean, I sometimes even ask ChatGPT for help. You know? I think it's necessary to know when you are out of your depth, you know? If you never, you know, think like, oh, I need to ask for help, you know, then you're never gonna learn. So it's kind of like pointless being stubborn, you know, about it. The shitty thing is that the problem is that Like, you would love it if the atmosphere actually looked like an atmosphere. Like, what has it been doing lately? Have we been thinking about this? What is the because we removed the thing from it. We need to put the thing back. Put that thing back where it came from, or so help me. We need to add inner radius plus this. I believe so. To both of them. I have that AI crisis, so feel stupid when you ask AI. I mean, yeah, I definitely agree with that. That's why I prefer to just like look stuff up on the internet, right? But when you don't understand the stuff on the internet, then it's kind of okay. So that was definitely incorrect, because the atmosphere is supposed to be up here. So that was definitely incorrect. So yeah. So outer radius factor is 1000. If I open a book and I read it, feel smart. Yeah, it kind of is an ego problem. I think that you have to kind of like get rid of that, to be honest. You know? Like, it's I don't know. At the end of the day, like, it's only you that you're going to, leave behind if you don't, make the sacrifice and just try and figure it out, right? It's only you're hurting by not doing it. Now, am I going to say like use AI to write the code for you? No, that's not what I'm saying. What I'm saying is that, it can definitely help you understand things. Now, do I think that AI is good for humanity? No. Humanity would be better off if AI had never, been created, like 100%. But we're not here to talk about that. I'm just saying that, like, can you use it as a tool? For sure. But, it's the same thing as, like, using the internet as a tool, It's, I'm trying to figure out how I can set my camera to start at 1000Z. And I don't know where I initialize my goddamn camera, which is really stupid of me, to be honest. But let's just set it here, because why not? Let's just set it at 1005. Just so that we don't have to keep on walking up to that. Now I'm wondering why the atmosphere doesn't look correct at that height, though, which is interesting. Oh, it is. It's just that we're off center. Yeah, I don't know why I decided to make the X and Y actually affect the skybox. Like I was going to make a physically correct fucking planet. I mean, we're not going to be doing that, but so, you know, I do think it's cool how you can take off from the planet now and then go into space and then select another planet and then go on to that one. Except it doesn't work right now, but you get the idea. It's eventually going to work, and that's the plan. It basically it's almost there. We just need a little bit more stuffs. Something I did notice was that we didn't actually start where I wanted us to start, where I just hard coded us to start, which is like, you know, really annoying that I can't hard code us to start at a certain place. Oh, it's because I. Oh. Very true. How many lines had I wrote in this project? A lot. I mean, there's a lot of like commented out stuff, so it's like hard to say. But it's got a lot of files, this one. So I'm not sure really. Maybe like 10K? Probably more. This one's probably inflated by like shaders. 10K is not a lot. 10K is not a lot. It's really not. It is really not a lot of code. Now, the game engine was a lot of code, but yeah. Oh, LinkedIn. Ah, yes. You're not. Oh, open your profile to stand out. Ah, yes. Exactly what I wanted in my email. The Linux kernel prototype? Not really. 10K is not a lot. 10K is not a lot of code. Okay, so that should fix that. Okay, so let's be honest here and let's take the X and the Y away from the thing. Let's just not worry about that for now. Now we should be able to fly. I guess we should check though the water. We haven't checked on the water in a while. I don't think that we're rendering it at all. Yeah, we literally just don't render it. I think that we were just skipping over it because of wanting to debug things. Okay, so the water is at the wrong level. Also, it looks weird. We probably want to render them differently when they're here. Also, this is super bumpy. The bumpiness is certainly interesting. Yeah, we probably want to render them differently when we're on a planet, huh? I don't really know how to do that per se. They do look a bit, you know. Also, technically, when we're walking around on the planet, they are moving around us. So if we walk far on a planet, then then uh then uh then the planet itself will move. So why is there no ground? Why is there no ground? What the fuck did I break? Oh my gosh. Let me make sure if first of all, let's fix the water. Supposed to add the planet radius. But we set it there, so you have to do this. Let's just make sure it's not a water thing though. Want to make sure that the ground breaking was not a water depth buffer thing. What covers it up there? Like, it's like there's something black that covers it up. And now we can't see it. Okay, so we obviously stopped rendering it at some point. And that's a big problem. It's a big problem. Planet atmosphere. Did we draw the where in? I feel like we're drawing it since it gets it gets placed there. I think it's getting occluded by the other thing. By the other thing, you know, the other thing. This thing with here. I think this GL position isn't enough. Or maybe this is supposed to be a 1. Probably not. No, that's probably not the truth. That's probably not. Or maybe, I don't. Yeah, see, so that still is happening. And then when we come out and then come back in, oh, it's still there this time. Oh, so I guess I was correct that had to be a 1 because we're doing GL less. With this, the weird artifacts are kind of interesting. Post process frag. We want to put the water back on. The Linux kernel prototype. Is that what I'm doing? Maybe that's what this is all about. This is all about Linux all along. Shout out Linux. Shout out Linux, people. Gotta love Linux. Who loves Linux? Yeah, that's the problem, right? Is that you're moving in space with this right on the planet, right? So I feel like your space in here should not affect the space outside, obviously. So I'm not sure how to fix that. Dude, I think, to be honest, we probably have like, you know, some maybe like 2 different positions, right? The position where you're on the planet and then the position that is like anchored in terms of rendering the outside world, right? Maybe it's like a different view matrix that gets computed. Oh no, come on. We can't be doing this. What are we doing this for? No, stop it. No, stop it. Why are we lagging? Oh, come on, man. Imagine spending all your time working on an application that you can't even run. What a fucking loser. What a fucking loser. Hey, this is pretty cool, huh? It's like a little, you know, a little, this is pretty sick, right? I like this one. Yeah, and then the lag hits, man. I don't know. I don't know how to work in the performance anymore. I mean, like my computer just fucking sucks. I what am I supposed to say other than that? The water definitely doesn't help for sure, but yeah, it's like fucking annoys the shit out of me. Because I do like everything to make it as inexpensive as possible, but there's not that much I can do. I really wanted to have it, reflect in the water, and so I had to put it on another FBO, and that the price of paying, that is expensive on Intel integrated graphics, so that's just a sucky thing, I guess. I could try running it on the AMD computer again. That would probably be better than this, to be honest. But yeah. That one's not much better though. That's the one that I stream off of. It's not much better. But I should make like a low graphics profile. That's what I should work on. Like I should make like it so that you can actually like turn the graphics down, Should make like a pretty water toggle or something. Probably wouldn't be like the most interesting thing to watch, but yeah, I should do that. Should probably do that. Anyway, it's pretty cool that you can leave the planet now. I do wish that the outer world kind of stayed in place. I don't know how to do it, to be honest. It's pretty complicated. It's not a very simple thing. Yeah, I wanted transparent water. And doing transparent water was very difficult without doing another FBO. It just wasn't possible without another FBO. You needed it, so I had to bite the bullet eventually. All right. Well, I'm out of steam for today, I think. I I melded them together today. I made the space come together with the, you know, the planet stuff. So now when you go, when you fly up, you can break through the atmosphere, and that works fine. Now the problem is, yeah. It's hard. It's hard to figure out how I'm going to do this next thing, which is, making it so that the sky is tied to the planet, right? It obviously makes sense. Like, you can just render it from just a view matrix at the planet center. That's fine. What happens though when you take off from a planet, right? Is that now your world position is obviously not correct, and so how does that work? Also, there's a lot of like floating imprecision problems when it comes to world position being like really far out, that we'll probably run into problems with soon. So there's that. Other than that, though, it should just work, and it does work, and it looks good. The problem is that, like, I don't know, it's just, it runs fine, it just overheats on my laptop, and I don't know how to stop that from happening. I think it might just be impossible to stop from happening, to be honest, which it's not what I like to hear. Yeah. I love playing around with it though. It's pretty awesome to play around with. I really got to make a thing that you can change the water level though. I keep on putting it off. I don't know why I haven't done it yet. But you can have a lot of FBMs now. Because now FBM is actually completely on a texture rather than it's on a texture rather than being in done every time. So you can really get away with a lot of cool stuff now. And also, since it's a texture, now everything works at like pretty fine frequencies, which is pretty cool. Also, I'm pretty glad that the chunking system now pretty much just works perfectly. But yeah. 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 It's honestly a big part of it is the water. Like if you turn off the water, then it's pretty fine, I think. I think a big part of it is the water, to be honest. This is pretty crazy. Like look at this crater. This is insane geometry, to be honest. All right. Oh, that's pretty cool. Little statue. Yeah, it's a little planet simulator, you know? Little space sim, little planet sim. I guess the next thing as well is like making it so that different planets have different kind of like seeds for how they generate their terrain. Like just like with different like randomness involved with them, so that you can kind of just like walk around on planets, just, you know, and always get like a different experience. I think that would be pretty neat. Bummer about the water though. I really wish I could get it to be cheaper, but there's actually like no way for me to get it to be cheaper. Like to get it to be transparent and cheaper. There's really nothing I can do. So I think I might just make it a toggleable thing. So that we can get away with it. Alright, I'm gonna peace out. I'm kind of tired. I don't know what I'm gonna work on next. I think I wanna. I don't know. I keep on trying to work on the performance, but it's not really satisfying, to be honest. I did want to do clouds. Like, do you see how fast it runs when my computer isn't overheating? It runs so fast. It's like how, like what is the FPS on this? Like it's like perfectly 60. It's just perfect. It's just such a bummer that, whatever. All right. All right, peace out.